Ini main. Saya sudah ubah ayat yang sekali sebab ada masalah dengan saya. Saya tekan in mind. Kita kau balik. Ya, betul. Ya, kalau tak ada.
Bos.
Ini dikumpul ya.
Ini ada keluar yang baru.
Ada yang baru. Kau cek.
Ya,
Keluar yang baru.
Adaklah ni pukul 12 tadi.
Kau cek mana ada apa? Kita punya ke
Yang ni kalau dia punya PowerPoint kita tak payah. Kita masukkan juga.
Ni before. Ini video.
Oh, video dia bentuk PowerPoint.
Video datang daripada PowerPoint.
Okey, dia cek.
Kita lalu tahu. Kita session
Pastikan pada ha.
Apa cakap mana sesi pagi ke sesi petang? Ada dua. Pagi, petang.
Ada.
Yang penting dia punya nombor paper dia kan, paper ID dia kan. Ini tak satu dua macam tu kan? Macam ni. Ini satu dua tiga kan?
Ada.
Oh tak boleh, okey tak?
Ada itu yang dalam email.
Lepas tu nak update, sebab kita nak bagi dekat MC yang latest. Kalau ada kau kena update file yang ni, sekarang session D ni dekat mana desktop. Sekarang session D ni kalau ada, mana kita kena tekan biru.
Yelah, yang semalam lah. Nanti lepas tu aku bagi kat kau.
Bagi kat aku, aku bagi kat MC.
Right.
Ini artis kan.
Apalah.
Jadi apa pelakon drama.
Yelah tengah live kan. Al, dah. Dah okey. Baik tu. Dah boleh off kamera luar.
You turn on the webcam. At the time
Hello, hi. This is call from Utah. I want to check with you guys whether the link for 2A, whether that session is already open.
Okay, welcome. Sapo, are you hearing me? Are you hearing me?
Yes.
Yes, sir. Okay, okay. Thank you.
Do you guys open the Google Meet session 2A?
So this is session 2B, right? What about 2A? 2A is the session open already?
Open yet?
This is 2B. This station is 2B.
Yeah, I know it's 2B. What about 2A? Is 2A open because we're waiting outside?
Hmm. Hello, everyone. So
Good
good
morning.
morning. Yeah, good morning,
Hello.
everyone. Hello, welcome everyone to the SCDMC 2024 6th International Conference. So my name is Muhammad Gali Aliu, being the chairperson of this important occasion. So as I have seen, some of the presenters are present here. So the first presenter is Kenlin Chen, and I have seen that she is present. So she is going to
Yes.
present of her work with the ID number 041. The title is Machine Learning-Based Phishing Website Detection, a Comparative Analysis and Web Application Development. So don't forget the time for presentation is 15 minutes and 5 minutes. Almost everything is 20 minutes. So you can finish. You can do in 15 minutes, maybe Q&A section 5 minutes. So you are highly welcome. The board is on you now.
Okay, so should I share my screen?
Yeah, sure.
Okay, so okay, can you see the slide?
Yes, okay.
Just to make sure, is the slide lagging? Is the slide changing?
It's changing.
Okay, okay. So then I can start my presentation on this paper with ID 41. Okay, so good.
So can
Good
you
morning.
open your camera, please?
Oh, sorry. Wait. Let me try. How should I do this? Okay.
Yes, great.
Okay, so good morning, everyone. My name is Kailin Chia, so I'm the presenter of this session. So I'm from Lee Kong Chian Faculty of Engineering and Science from University Tunku Abdul Rahman, Utah. So I'm here to present our research on machine learning-based phishing detections. Website detection, comparative analysis, and web applications development. Okay, so the presentation will cover the following topics. So we have an introduction to the topic, a review on related work, then a research design, then methodologies, and then followed by the results and discussion, then finally the conclusions and some future directions. So phishing is actually a rapidly growing cybercrime that targets both personal and financial data. So according to the IBM cost of data breach report in 2022, so phishing is actually the second most common attack, costing organizations an average of 4.91 millions per incident. So our study aims to enhance phishing detections by comparing three machine learning models, autoencoder, XGBoost, and also random forest. The objective is actually to identify the best performing model and integrate that into web applications for real-time phishing detections. So in the field of phishing detections, list-based techniques is always the traditional approach. So these methods typically involves comparing URLs to a predefined whitelist or blacklist. So for example, then the study by Tao is demonstrated the effectiveness of automated allow lists, achieving a high true positive rate. And then Jin and Gupta also further refined this approach, reporting an impressive of 86.02% positive rate while comparing the URL's parent's domain to specific whitelists. However, these methods have its own limitations. So they actually rely heavily on users' participations and cannot actually detect new emerging phishing websites. And then this method can also produce false positives. For example, some legitimate website that is actually not included in the whitelist might be mistakenly flagged as a phishing website. Next, machine learning also has gained prominence in phishing detections due to its ability to analyze large data sets and detect complex patterns. Various studies have also highlighted this efficiency of machine learning models. So, for example, in the research by Stoff, he utilized a random forest classifier optimized with particle swarm optimization, PSO for feature selections, and TPE for hyperparameter optimization, achieved a 99.33% accuracy. Then Kumar also employed a random forest classifier that successfully detected phishing websites with 97.7% accuracy. Then an ensemble model combining random forest, extract tree, and also XGBoost was proposed by Rao and Pais, which evaluated blacklist and heuristic filters, achieving an accuracy of 98.72%. And despite this high accuracy, so these machine learning methods are very computational intensive. So the complexity of combining multiple algorithms can negatively impact the system efficiency. So, and therefore making it challenging to actually deploy that in real-time environment. Next, followed by deep learning. Okay, deep learning also model has also been explored for phishing detections due to their capability to handle large-scale data and complex features representations. So, for example, in the study by Feng and Yue, they utilize recurrent neural networks (RNN) and achieve a remarkable accuracy of 99.5% in detecting phishing URLs. And then in the study by Macy, he tested a multi-layer perceptron neural network (MPN), achieving a 93% accuracy during testing. However, these learning approaches have their own disadvantages. One of the major issues is the extensive training period due to the complexity and the size of the models. And then additionally, the feature set used in this study can also be limited, as seen in the study by Feng and Yue, where only 17 features were extracted from a dataset containing 1.5 million URLs. So another interesting approach in phishing detection is based on visual similarities. So this method actually involves analyzing those visual features of web pages and to identify phishing websites. So, for example, in the study by Marufi, he explored a visual similarities-based detection, which demonstrates high accuracy when using all these visual features extracted from web pages. Next, in the study by Abdenabi, he developed the LBET model, which can achieve over 97.5% detection accuracy using visual similarity techniques. Okay, so however, these techniques also have their own disadvantages. So they often relied on third-party search engine filtering, which can produce inconsistent results depending on the timing and the nature of the query. So from the review of all these related works, so it showed that while existing methods offers high accuracy, they often suffer from limitations like high computational demands, reliance on static lists, or long training times. So there is a need for an adaptive real-time phishing detection method that can handle the dynamic and also evolving natures of phishing attacks. So our studies aims to address this gap by integrating machine learning models with traditional methods, offering a more balanced approach to phishing detections. So for our study, we picked three machine learning models, okay, the random forest, attributes, and autoencoder. So each of them brings something unique to phishing detections. So for the random forest, it has been proven time again in cybersecurity, especially in phishing detections. It can handles a lot of data and complex features really well, and is tough to overfit, which means it gives reliable results even with noisy data. Next, XGBoost is all about speed and precision. So it is actually great at finding complex patterns in the data without overfitting. So it is actually a popular choice because it is flexible, fast, and tends to outperform other models in phishing detections, and as shown in several findings. Then the third one is autoencoder. So autoencoders are actually the anomaly detectors here. So they are great for spotting small differences in phishing websites because they learn what is normals looks like, and then they try to flag anything that doesn't fit into that normal. So, and then they require less manual tweaking, which is also a big time saver. We chose this model because they have strengths that cover different aspects for phishing detection. Random forest and attributes can handle the heavy lifting with structured data, and while autoencoder adds another layer of anomaly detections. So in this research for our data set, we use this data set full CSV from Mendeley data. Okay, it contains over 8,000 instances with approximately 34.5% phishing websites. And then we employ the bidirectional elimination BDE method to reduce the 111 features to 59 significant ones, focusing on the key features like URL shortens or quantity parameters. So all these features are related to the URL format, and those special characters are actually very crucial for detections. So the graph here shows those significant features. So for example, the URL in this URL shorten coefficient, it is 0.512. So meaning that shortened URL may increase the likelihood of phishing. And then the negative coefficient in this quantity parameters suggests that if the links have an association with the @ symbol in the parameter, it will be a decrease in the phishing likelihood. So after we have selected the data, so as mentioned in the previous part, we have chosen these three models. Okay, so we implemented these three model, random forest, attributes, and also an autoencoder using various hyperparameters optimized for each model. So random forest was set with 300 estimators with a maximum depth of 40. XGBoost had 200 estimators and a learning rate of 0.1, while the autoencoder model have used 128 hidden layers with 100 epoch. Okay, so all the details of all the other hyperparameters are also shown in the tables in the slide. Then after that, this data set was split into 80% training and 20% for testing, okay, with SMOT applied to handle imbalanced data. Then we evaluated the model based on the accuracy, precision, recall, and also F1 score. So the random forest model achieved the highest accuracy of 97.03%, with an AUC of 99.51%. Then XGBoost also showed a strong recall at 97.24%. And while autoencoder performed well, but then it does not surpass the other two models. So the figure here shows the graph for the AUC. So we can see that a random forest has the highest performance. Then here, the precision recall curves also shows the XGBoost's highest recall, making it effective in minimizing false negative. Okay, so after we have tested those three models, and then the model we have chosen to be used in our web application development is actually the random forest classifier. So then we developed that web applications by integrating that random forest classifier together with the Google Safe Browsing List, which acts as the traditional detection method. So in this web application, it's actually a browser extension. So these applications allows user to actually submit the URL, which are then accessed by the classifier for phishing attacks, phishing risk, and then at the same time cross-reference with the Google Safe Browsing List. So this web application was developed using Flask and other libraries, okay, providing a comprehensive safety assessments of URLs. Okay, so the figure here just shows the simple interface of the web applications development when it's being used in the web browser. So after we have created that web application, so we have tested that with 50 phishings and 50 legitimate URLs, which can actually achieve 97% or accuracy rate. But then, however, it actually misclassified 3 phishing URLs as legitimate, indicating there's still room for improvement for these web applications. So we recommend developing a dynamic system that update the features extraction functions regularly to adapt to the evolving phishing techniques. And then expanding the testing data set will also help to evaluate the classifier's effectiveness against the broader range of phishing methods. So in conclusions, our study demonstrate the effectiveness of machine learning models, so particularly random forest, XGBoost, and also autoencoder. So the integrations of Google Safe Browsing List enhance the practical applications of our web tool. Future works will explore real-time behavioral analysis and advanced deep learning techniques to further improve the detection accuracy. Okay, so here's a list of the references of all the previous studies. Okay, so that's the end of my sharing in my presentation. So thank you for your attentions. Okay, please feel free to visit the provided links for more information about our research and the university. Okay, thank you.
Okay, thank you, Mrs. Kathleen Chen, for a wonderful presentation. So I can now I can ask the floor to all the audience to ask any question if there is, or the wonderful presentation. So if you have any question, feel free to ask her. She's ready to answer everything. So may I ask you, Mrs. Kelling Chen, what are the, my question is that what are the possible challenges you experienced during this research work?
During this study, is it?
Yes, yes.
Maybe the challenges. One of the challenges last time we have faced is that we are picking the data set actually. So we try to find some of the available data set to train the models to for the phishing list of, for example, the list of phishing sites and also legitimate sites. We also we found that is problem in finding the suitable one, I guess. Yeah.
Mm, that's great. Okay. So thank you, Pebe, for very wonderful presentation.
Okay.
So in the absence of questions, so maybe we should move to the next presenter. So the next presenter is Mr. Mudofe Agaw. Mr. Odede Mudoipe, are you with us?
Yeah.
Okay. So now you are the next presenter. So the paper title or the paper ID is 004, and the title is Detection of Phishing Websites from URL using Hybrid Ensembling Based Machine Learning Technique. So now you can share the slide and start presentation. Yeah, highly welcome.
All right. I'm trying to share my
Your slide.
yes.
Okay.
Hold on, please.
Okay.
Sorry, please. So can you share the video? Please hold on. I'm trying to open it on my system.
Oh, okay.
Sorry, please.
Okay, we are waiting.
All right, thank you very much.
Okay.
All right. Can you see it, please? Can you see my
No.
screen, please?
No, not yet.
Wow.
Yes.
You can see it now.
Yes. Yes.
All right. Thank you very much.
So you can make it slide mode. Slide mode.
Okay.
Just down. Yes.
All right. Good morning. My name is Mutupe Agago, and I'm presenting from Nigeria, from Olusegun Agago University of Science and Technology in Nigeria. And I'm here to present this paper that is titled Detection of Phishing Website from URL, Hybrid Assembly Model-Based Machine Learning Technique.
Okay.
And
Sorry, please. Sorry for interruption. Can you make it to slide mode? Still, we are not seeing it in slide mode.
Because she shared
oh,
window, not the screen.
Because you share as a window, not a screen. So I think that's a problem.
okay.
So even if you share it in as a window, then you can go to the slide mode icon and
Okay, please.
so share entire screen.
Okay. It's not. It's not giving me access to share as a screen. Okay. Sure. Can you see it now?
Yeah, we are seeing it, but not in
Okay.
slide mode. Not in slide mode.
Okay. Okay, I'll put it in slide mode now.
Yes. Okay.
I think it's better.
Yeah. You go to the yes.
Okay.
Yes. Okay. It's okay. You can.
All right. So this is my title, and I'm presenting from Nigeria, as I've said. Then, to do this introduction, to do this presentation, I have the following outline: my introduction, aim of the study, related work, design methodology, results, conclusion, and my references. So I go to the introduction. So due to technological advancements, the internet has become one of the normal ways of performing daily activities, and phishing is the most significant issue in the field of networks and internet. And often we know that malicious people exploit the vulnerabilities of the internet to manipulate people into collecting their confidential data. One of these techniques used by these malicious people is known as phishing and also can be called web phishing. So web phishing is a cyber attack that generates fake websites to imitate a trusted website to steal sensitive information such as usernames, users' password, and their credit card information, and lots more like that. So detecting phishing is important because it has become the norm for people who want to access online services. So if they access online activities without being able to detect a trusted website and the one that is not trusted, they may fall victim of losing their information to fraudsters. So therefore, there is a need to help safeguard people from unknowingly releasing their information to the hand of malicious people. Now, several researchers have carried out studies in detecting phishing websites, including using machine learning. Authors like Ramana et al. 2021 and Kumar et al. 2028. In this study, the authors used heuristic and machine learning based technique to detect phishing. So out of those techniques used to detect phishing, machine learning technique proved to be prevalent and supported by Sidhu et al. 2020. So machine learning techniques can be used to detect phishing from a website URL, the content of the website, and etc. So a typical example of using machine learning to detect phishing is evident in the work of Kumar et al. 2018, where authors use machine learning technique to detect web phishing. However, of all these researches that was revealed, we saw that low model accuracy was obtained. So, going to the aim of the study, this research aim to build upon existing research in predicting website phishing from URL, and our major contribution for this study is as follows: develop a hybrid ensemble phishing URL-based cyber attack detection, which we proposed in the research in order to be able to prevent crime and protect people's privacy. The research employs three base classifiers: the CAT boost, the SGB boost, and light GMB. And also, a voting technique was used to combine the base classifiers to form an ensemble model to classify the threat of phishing URL and accurately carry out predictions. So the methodology that we proposed here was evaluated using evaluation parameters such as accuracy, model accuracy, precision, F1 model, F1 score, and the confusion matrix was also used. So going to the related work, a study conducted by Al Jama et al. 2023 developed a machine learning model to predict web phishing using 6 machine learning classifiers, which are the naive Bayes, ANN, decision storm, KNN, J48, and random forest. And they tested the work on 3 web phishing datasets. The research contributed to is the research contribution is to evaluate the performance of different machine learning classifiers which have listed which I've listed earlier for detecting phishing using multiple datasets. However, we discovered that the limitation of the research is that the authors did not compare their development with other research studies to see how their model performed. So the performance of the model was not determined. We couldn't determine it. So we consider it as a weakness of that study. Then Pandy et al. 2022 also developed a hybrid ensemble model to predict phishing from URLs. So they trained the model using 20,000 instances of legitimate and malicious URL, and then achieved an accuracy score of approximately 85% and a recall score of 84%. So the hybrid model was a combination of 4 different base classifiers, which are multi-layer perceptron, SVM, decision tree, and random forest uh, classifier. So the weakness of this research is that the data set that they used to test the work was not representative enough. So then the accuracy score of the work is 85%, which it's a bit considered to be um, a bit low, because some other classifiers got above that. Then going to the design of our work, the proposed model for web phishing follow a sequence of stages from data collection to feature extraction, feature selection, model selection, and training of the model as shown in figure 1. So they are listed here. We have data acquisition, data cleaning and transformation, exploratory data analysis, splitting of data set into train and test set, base model selection, base model testing and evaluation, then building the proposed model, then we also carry out the evaluation. So this is the figure which I said earlier, which is showing the architecture of the work from when we supply the data set, go to data preparation, then the assemble model, which is combined using CAD-BOOST, LIGB, LIGBM, XGB boost. Then after that, it classifies the URL to either phishing or a legitimate site. So this slide talks about the description of the machine learning classifier used. Basically, we consider the CAD-BOOST, XGBoost, and the LightJBM because of their ability to be able to accurately classify phishing website to either phishing or legitimate website. So we use them basically because of their ability to be able to classify accurately. So the data set that we used to test this work consists of a total of 11,430 records, and it also comprises the both legitimate and phishing website. And specifically, the data set was designed to facilitate research on detecting phishing website with a focus on attributes relevant to URL analysis. From this data set, a total of 58 features were extracted, which are encompassing various aspects, such as URL structures, domain characteristics, and others. So the performance of the model was evaluated using these metrics: the accuracy score, the precision recall F1 score, and the confusion matrix. So this is the formula that we used for our calculation for the accuracy score, which is the number of correct predictions over total number of predictions. Then the precision, which is the true positive over true positive plus the false negatives. Then for the recall, we have a true positive over true positive plus false negative. And for the F1 score, we have 2 multiplied by precision multiplied by recall, all over precision plus recall. So these are the formula that was used for calculating, for evaluating the performance of the model. So in our results, we were able to get an accuracy score of 93% and a recall of 92.2%, precision of 93.4%, F1 score of 92.8%. So when the model was compared with other existing classifier like the AdaBoost, Decision Tree, XGBoost, LightBoost, CADBoost, we saw that the hybrid model performed better, giving us a higher accuracy score when compared with other classifier, or when we compare them independently, as in those classifier independently. So the combined one, the hybrid model performed better. So we also move further to compare the performance of the model with some researches that were done in before, like the Basit et al. 2020. We discovered that our model, which is the combination of CADBoost, XGBoost, and LightBoost, when we compared with the work done in Basit et al. That used the KNN and random forest classifier, it was discovered that our model performed a little better than the work presented by Bassett et al. 2020, giving us accuracy score of 98.6% and recall of 98.7%, precision of 98.5%. When we tested, we compared it using the data set that this researcher used. So this is what we saw that the model performed better than the what was presented in Bassett et al. 2020. So we also compared it with Al-Jama et al. 2023, and we discovered that we have the accuracy score, recall, precision, and F1 score that is higher than what was presented in Al-Jama et al. 2023. So this also shows our the confusion matrix of uh, of the model. Then, in conclusion, this study has developed a hybrid machine learning model that can accurately predict phishing URLs. So the hybrid model consists of three place classifiers, which are the CatBoost, the Live GBM, and XGBoost. And also, the hybrid model was trained on dataset with 11,430 instances of legitimate and phishing URL with 58 features. Metrics such as accuracy, precision, and recall were used to evaluate the performance of the model. Upon evaluating the model's performance, the proposed model achieved an accuracy score of 93%, which I've said earlier, on the dataset that was used. And also, after comparing it with other datasets used by other researchers, the proposed system achieved a higher accuracy score than the previous research done. So the accuracy score achieved was 98.9%, like I've said, when it was compared with Bassett et al. And finally, the proposed system was deployed as a web app for testing. So these are my references. So thank you for listening.
Okay, thank you, Modofe Agagu, for the
Yeah.
good presentation.
Yes,
So
sir.
I think I should handle the mic to the floor if there is any question regarding to this research finding. So please, anyone has a question, he is free to ask. The author is already here for us. So thank you for good presentation from Nigeria.
Thank you very much.
I from Nigeria too.
You're from Nigeria?
Yeah, of course.
Wow, that's good to hear.
Yes.
Here in Nigeria, we are in the midnight now, so I had to wake up to do this
Exactly, I know.
presentation so I don't miss it. So the time
Yes,
right now is 4 a.m.
exactly. Because we are ahead of you like 7 hours.
Yeah, 7 hours ahead. So I had to
Mm,
set my alarm to wake me up so that I don't miss the
the
presentation.
presentation, yes.
Yes.
So may I ask you, please?
Okay.
My question is that why you use only one data set? Why you didn't use other data set, like maybe apart from that data set, use another data set in order to test your model?
We actually discovered that that data set that we used was representative enough. And also, after we were through with the work, we also tested it with other data sets that
Mm.
those researchers that we compared our work with, they used.
Okay.
So basically, we can say that we tested the work using three other data sets because the main one that we used that contained 11,000 and more um, uh, uh, features, and we also tested using the data set of those two researchers that I presented here. So we can say that
Okay.
we used three types of data sets to test the work. And that was why we're able to come out with that accuracy score and the
Accuracy.
performance evaluations that was presented in the work.
Okay. I understand. That's great. So
Thank you
please,
very
any
much.
question? Thank you. So any question, please? So I think in the absence of question, then we can say thank you for the wonderful presentation. So
Yeah, thank you very much.
see you again.
Thank you very much.
So thank you. So
Yeah.
our next presenter
Can I
is
have your email or your contact details so that probably we can have some further discussions?
okay, sure. So maybe I will share with you in the chat.
All right.
So yes, in the
All right.
chat. Yeah,
All
sure.
right. Thank you very much. Yeah,
Okay,
thank you.
okay. Mm, yes. So the next presenter is, I think, as I have seen, he's ready. Well, already we sent the reminder to you, Mrs. Saida Roslin. So, Mrs. Saida Roslin, she's the next presenter, and I have seen that she already shared her slide. So the title is an automated class identification for re-identification for privacy preserving data. So, Mrs. Saida, you can go ahead and start. Don't forget the time for presentation and the question and answers is just 20 minutes.
Okay,
So,
all right. Is it my voice is clear?
yeah, your voice clear. Okay.
Okay. So
Mm.
we start now. Okay. Just a moment.
But you can make it to slide mode.
Uh, just a moment. All right. Is it in the slide mode
Not yet.
or not yet? Not yet.
Share the full screen.
Share the full screen. Okay.
Yes.
Just a
Mm.
moment. Okay. So this is a full slide.
Mm. Yes.
Okay. Alright, thank you. Assalamualaikum warahmatullahi wabarakatuh, and very good morning to Chairperson and all here. So I'm
Okay.
Sada Nafisa, which Rosla will be present an automated QID for privacy preserving data. Alright, so this is my overview of presentation. Uh, So for the introduction, nowadays we have the data is a rapid growth of a data generation. So we have two kind of sources, which is public sources and private sources. For example, National Cancer Center, hospital, patient information. So the data is very important and can be used for data mining or data analysis. And then it will be increasing security and privacy concerns. So this is a privacy concerns. We have information disclosure, which is we have three kind of disclosure, which is identity disclosure, attribute disclosure, and membership disclosure. So for attribute disclosure is linking QID with other data set to identify an individuals. And then for membership disclosure is identifying if an individual is in a data set. Okay, so this is the overall of privacy preserving method. So basically, we have the identification, which is generalization and supervision. We have anonymization technique, we have a perturbation technique, and also uh, privacy preserving is very important to prevent identity theft and misuse of sensitive data, and then to build an trust and reputation between data subject and organization. So, sequence of not preserving privacy, it can lead to re-identification risk, and then data breaches, sensitive information can be exposed, leading to financial and reputational damage. So in the data set, we have four kind of group or classification, which is we have a DID, direct identifiers. We have a QID, other indirect identifier that can be combined to identify an individuals, for example, age, gender, zip code. And then we have sensitive attribute, and then we have a non-sensitive attribute, which is data do not harm an individual. Okay, next, this is a problem statement of this research. Okay, uh, manual QID selection, which is previous work, they tend to choose manual QID selection in their experiment, which is high risk of re-identification due to inconsistency and human error. And then information loss, balancing privacy with data utilities remain a challenge. And then current method limitation, which is the existing technique often overlook the need for proper QID selection. It will be impacting data validity and utility. So the gap is a need for systematic QID selection, maybe based on the identification risk to reduce subjective judgment and minimize data loss. So this is a proposed solution. So we want to improve the identification efficiency and reduce re-identification risk, and then enhance calculation of re-identification risk for single stone. And then for impact, better balance between data utility and privacy. So this is a previous work. Okay. The first one is proposed by the Jun, proposed uniqueness and influence calculation in selection of QID. And then this paper assesses the impact of the determination scheme on data utility. However, still use manual process, potential for subjective bias. Okay. And then for the second paper is a combination within the power set, maximize the number of people in the data set. So the advantage, this is the formal selection procedure for QID attribute based on the probability. Okay, however, the disadvantage is, the limitation is still manually choose the attribute for the QID. So could be leading to potential inefficiencies. So this is another example, which is using specific criteria related to unique occurrence, single stone in data set. Okay, by selecting the minimum set of attributes that expose the highest number of single stone, it's aimed to strike a balance between data utility and privacy. Okay, the disadvantage is this paper still involve manual intervention because they are focused on the specific set of QID attribute, for example, date of birth, zip code, and gender. Okay, may not scale well with the largest data set. So this is a research work. We have a three stage, which is theoretical analysis of pure experiment. We have a model development. We have assessing and analyzing the outcome. So this is the step of process. Okay, the first one we do is data processing, which is we're using adult and bank marketing data set. Then we standardize it. Okay, correcting inconsistency, standardizing the values.
هذه قراية يعني نقرأ.
Taxonomy replacement. Okay, mapping specific terms to standardized taxonomy. Okay, and then the second step is a frequency calculation, which is we calculate the uniqueness assessment. Okay, calculating the frequency of distinct super in each attribute, assessment of uniqueness level. And then the second one is a quantitative understanding to determine the uniqueness level of each attribute. Okay, for the third step is re-identification risk score computation. So Here we calculate the score calculation based on frequency of distance suppose, and then risk assessment, which is the highest score indicate highest re-identification risk. Then for the formula is summing up the inverse frequency of the distance value. Okay, the fourth step is the QID selection. So here we do the risk prioritization, selecting attribute with the highest risk score. Then for the evaluation, using maximum risk score to measure re-identification probability. So the criteria is a risk score more than one. We conclude that one is a maximum risk. Okay, for the evaluation, we are using the ARX tool, which is a data anonymization tools, okay, to preserve the data, to preserve the selected QID selection. So ARX tool evaluating the effectiveness of selected QIDs using ARX tools, and then the matrix we are using is a re-identification risk for single stone, success rate, and information loss. So in ARX tools, we have a attack simulation for testing against various attack model. Okay, so this is a part of a selection of QID. So the formula result is re-identification risk score. Okay, so we calculate frequency of distance record, compute re-identification risk for each attribute, and then we classify attribute with the highest risk as QID. Oh, okay, so the proposed estimate, the formula estimate the overall risk of the identifier individuals in the data set based on the attribute. So the probability of the identification, so the maximum risk score is, the value is 1. So indicating the highest potential for re-identification. So here in the selection part, we have a threshold to determine the inclusion of QID attribute. So the criteria, if the re-identification score, risk score, more than 1, so the attribute is considered as QID, posing a highest risk of re-identification. And then if risk score is less than 1, so attribute is not considered as QID. So this is an experimental evaluation. We are using generalization technique to preserve the selected QID in ARX tools. So basically we have 3 model simulation, which is prosecutor models, target specific individual with pure knowledge, and then generalist model is target specific individuals without pure knowledge, and then marketer models aim to identify large group without specific pure knowledge. So this is the result. Okay, this is the result comparisons of preservation technique for different attacker models of Hadoop data set. Okay, so for Hadoop data set, after we do the calculation, the QID attribute of Hadoop data set is age, hour per week, capital gain, capital loss, and final rate. So in the attacker simulator, okay, we can see here three attacker models. So before we preserve is almost 100%, which is lead to risk re-identification, and then after we preserve, the number is become smaller. Okay, this is the attacker models for bank marketing data set, which is after we do the calculation, QID attribute is age, balance, and duration. So we do the tools, do the attackers model simulator, okay, for simulator generalist, and then before we preserve is 100%, and then after we preserve, the value becomes smaller. Okay, so this is a comparison with the existing work, okay, of a risk in single record before and after we preserve the QID for Hadoop dataset. So set 1, which is a paper 1, Tahido Hassan and imposter, the attribute is the age and sex, and then sex or gender. And then the second paper is a multiple attribute. You can see it in the screen. And then for the research work or purpose work, also multiple attribute. So before we preserve is 100%, have a risk re-identification. Okay, and then after we preserve the QID attribute, okay, they have the value here. Okay, information loss score. Okay, uh, this is the from the data just now. Okay, so for Tahidul, the risk dropped significantly to 12.5, showing a strong reduction in re-identification risk when only age and sex are preserved. Okay, for the second paper, risk reduced further to 7.692, okay, which is suggested including a broader set of attributes for preservation leads to a lower re-identification risk. And then the information loss score is 0.787, which is highest loss of the utilities compared to others method. And then for the proposed work, which is the research work, the risk dropped to 5.882, indicating that automated selection of QID for age, hour per week, capital loss, capital gain, and final weight result in the lowest re-identification risk among the three approaches. Okay, so the information loss is a 0.765, slightly lower than second set. Okay, so this is a comparison with the existing work. In single record before and after we preserve the selection as the QID, the selected QID, okay, for bank marketing. So the first paper, the Hassan and imposter, the attribute is age, and then the second one is the age, job, education, and marital status. For the automated I mean for the research work, proposed work is age, balance, and ratio. So this is the record. So the first paper risk dropped to 14.286. Okay, after just preserve one attribute only. Okay, it's like a relatively high risk, residual risk. Okay, however, it's beneficial for maintaining data utilities. Okay, but comes at the cost of highest residual risk. Okay, and then for the second paper or second work, they are preserved age, job, education, and mental status. Risk is reduced further to 11.111%, and better reduction than the first set. Okay, and then the information loss is much higher, 0.757, indicating a significant reduction in data utilities. And then for the purpose work, okay, this method reduces the risk even more to 4.762. Okay, when preserving the attribute, okay, the information loss here is slightly lower, 0.731 compared to the second paper or second work. So indicating that the intermediate method achieve a similar level of privacy protection, but with slightly better preservation of data utility. So this is the discussion. The effectiveness of the proposed method, the method outperforms traditional QID selection method by dynamically adapting to data characteristics, and then elimination of human bias, okay, leading to more consistent and reliable anonymization, balancing privacy and utility, okay, ensure a better balance between privacy protection and data utility. Oh, that's all from me. Thank you. Hello?
Okay, thank you. Thank you, Shaida, Nafisa, and
Yeah.
Roslyn. Thank you for the wonderful presentation. So I can handle the mic to the floor if there's any question. So the author is ready for us to answer, right? So is there any question? Okay. So Saida, thank you for the wonderful presentation. I think due to the time you have taken, so I cannot ask
Okay.
So
Yeah,
thank you
sure.
very much for the wonderful presentation. And
Okay.
maybe we can move to the next presenter. But what I have seen is that the author of our next presenter is not yet joined. So I think I can handle we can play the video for the ID number 050. For the ID number 50, the title Enhanced Network Instruction Detection System through Dimensionality Reduction. So since none of the authors joined, so we can play the video. So thank you.
Hello everyone. I'm going to present a paper for the SCDM 2024 conference. The title, the paper is Enhancing Network Intrusion Detection System through Dimensionality Reduction. My name is Prof. Muslah Abul Haj, Al-Ahliya Amman University, Amman, Jordan. As you know, a considerable number of people's lives rely on the cyber world. However, cyber world is facing a serious cybersecurity issues. Some of these issues like DOS attack, malware, phishing, and many others. So therefore, we need many tools or cybersecurity tools to protect us from these attacks. Some of these tools, very well-known tools, antivirus, firewall, and intrusion detection system, and many other tools, of course. What is intrusion detection system, which our interest in this paper? Intrusion detection system, or IDS, is a network security tool that monitors network traffic and devices for non-malicious activities, suspicious activities, or security policy violations. For example, if we have attackers like here, or any normal traffic, when it comes through my network to my server, before it reach my server, it has to go through IDS. IDS will inspect this traffic to check if it's normal traffic or attack traffic. So this is the main rule of the IDS. So what about IDS or the current IDS? What techniques are they used to protect us from the attacks? For the attacker, from the attacker sides, they use advanced techniques. These techniques are used the AI to breach our network, to breach our systems, to breach our data. Therefore, the cybersecurity tools or the security tools also must use the AI, so we can countermeasure the attacker the techniques. Thus, the IDS, the current IDS, or most of the current IDS are using machine learning, which is part of the AI. So what is machine learning? In short, machine learning allows the computer system to learn from the previous data or the history to predict unknown attacks or the new attacks. So this is in short what is machine learning. However, one of the problems that machine learning has to deal with large size of data. When it deals with large size of data, it this result like low performance. Let's say low performance. The IDS performance will be very low. Therefore, we need techniques to handle this issue. Part of the machine learning techniques is what's so called feature selection techniques. This feature selection techniques reduce the size of large data by selecting only the important features from large set of features. Let's say we'll have like 100 features. Many of these features are not important, and some of these features are important. So the rule of feature selection techniques is to choose only or to select only the important features from the large set of features. So in this paper, we are going to use two well-known techniques for feature selection. The first one is WOA, and the other one is HHO. We will apply these techniques for feature selection on certain benchmark and compare the results from each techniques. So to see which techniques or to find which techniques will give us better results in detecting the attacks when it's used with IDS. So this is the main, let's say, the main objective of the paper. This is the model which summarizes the entire work in this paper. First, we will use the NSLKDD dataset as a benchmark for our testing, which is a very well-known dataset for IDS. The NSLKDD dataset contains 40 features. We will apply pre-processing on this dataset. First, we will apply label encoder, which is used to transform the textual data to numeric. Then we will use min-max scaler, which is normalize the data into same range, normalize the numbers into same range. Then this is our main contribution, or our main objective is to apply the HHO algorithm on the NSKD dataset and WOA on the NSKD dataset. As we can see, when we apply the HHO on the NSLKD dataset, the number of features is reduced to 13 features from 40. And when we apply the WOA to the NSLKD dataset, the number of features reduces from 40 features to 16 features. To see which algorithm, to find which algorithm HHO or WOA has chosen the best features, we'll use the SFM classifier. So SFM classifier will be applied on this subset of features and this subset of features to find which algorithm, HHO or WOA, give us best result with IDS. These are the metrics which will be used to find which algorithm is best. As we can see from the result, the HHO and WOA has achieved high accuracy. However, HHO has achieved better accuracy or slightly better accuracy than WOA. Therefore, we can say like both algorithms are very good, but HHO is better. And regarding the other metrics, all other metrics are in the paper. They give almost the same result. HHO outperformed WOA with IDS system. And thank you. This is all for my presentation. Thank you.
Okay. Okay, thank you for the presentation. So I think since it is a video, not a live, so if you have any question, you can put it in the chat clip so that we can, the technical team will handle the question today also. So thank you very much for the waiting and for the yeah. So the next presenter, as I have seen, is here with us, Mr. Salama A. Mustafa. So the title, the paper title is the ID number of the paper is 30, and I see Doctor. And
Assalamu alaikum warahmatullahi
Walaikum
wabarakatuh.
assalam warahmatullahi wabarakatuh. And the title is multi-level mock-on simulation model for air population index prediction of a smart network. So,
How are you, Dr. Gali? Been a while.
Alhamdulillah, Doctor. Welcome. So the floor
Okay.
is for you,
Assalamu
Doctor.
alaikum warahmatullahi wabarakatuh.
Walaikum
And good
assalam.
morning, everybody.
Good morning.
I am today here to present again in SCDM 2024. I had 2028, 2022, and this is 2024. 2028 with Dr. Gali when he was master student.
Yes.
You remember. Okay, so without further ado, actually, this paper belonged to our PhD student in UTHM, and Alhamdulillah, he passed his Viva with minor correction. So I am presenting on his behalf. The title of the presentation is Multi-Level Monte Carlo Simulation Model for Air Pollution Index Prediction of a Smart Network. The authors are the first one, the student, Mustafa Hamid Hassan, me Salama Mustafa, Prof. Rusaida Ghazali, and Dr. Muhammad Zainouri, and Dr. Nur Aida, and Prof. Aida Mustafa, Dr. Muhammad Jubair, and Dr. Hussein. Okay, most of us are from University of Hussein, Malaysia, and Faculty of Computer Science and Information Technology. Okay, the outlines of the presentation are introduction, methods, modeling, results, and conclusion. Basically, our work is about evaluating air pollution index in a specific area, and the data should be collected from different parts of that area. It can be city, state, or country. Okay, and we assume that these data collected by smart network, such as IoT network. Our main aim is to evaluate the air pollution risk and give early alarm about air pollution. So people and related agencies can take action. Okay, so in our study, we tried different type of methods before we come up with using Monte Carlo simulation and multi-level Monte Carlo simulation. We tried several statistical and machine learning methods. Okay, so after many attempts, we found that Monte Carlo simulation is more sensitive with data similar to air pollution. have the same properties, and it is very good predictor for short-term prediction, okay, not long-term, and that's why it is suitable for predicting API. We try other methods, and they have their advantages and disadvantages, so we decide to stick up with using Monte Carlo simulation. Okay. And for our testing, we use the ambient air quality dataset that they use IoT technology to collect data, and this data is real data and from China. Actually, we tested different data, even in Malaysia, all states. But for this paper, we are only presenting the result of the China case study. So the methods that we use for prediction of air quality, air pollution index, we use Monte Carlo simulation, and the upgraded version, the multi-level Monte Carlo simulation. The dataset, as I mentioned, it is ambient air quality dataset. It is extracted from 10 locations in Beijing, China. Number of attributes for this data is 18, and the predicted class is API, and you can see in this figure the area bounded by the blue and orange curves. So this is the area that has the ambient system to collect the data, and it is time series data, of course. So the performance evaluation matrix that we use means absolute error, root mean square error, and coefficient of determination and processing time. These are the standard matrices for evaluating prediction methods or models. Okay, now just for your info, what is the difference between Monte Carlo simulation and multi-level Monte Carlo simulation? Actually, the difference is in how the algorithm runs. The functions and the procedures are same. Okay, in Monte Carlo simulation, actually the Monte Carlo simulation will create a mathematical model, and this mathematical model process many times using randomized function to the given data. So the sample, it will be randomized plus minus and compare with the output. This is the job of the mathematical model. And by doing this many times, even million times, the mathematical model will capture the thresholds and the boundaries and the range of input and outputs. And by this, it can predict any output from future inputs. This is how Monte Carlo simulation works. But Monte Carlo, if we have raw data, Monte Carlo, and this is the columns of, let's say in our case, is we are using air quality parameters like ozone, particulate matter, and nitrogen dioxide. So each one of them will be the time series data of each of them. Monte Carlo simulation will process one by one each feature until they finish all the feature sets. And during this time, it will generate outputs, and this is the predicted output. In multi-level Monte Carlo simulation, the process will happen in parallel for all the features, and it can generate not only relationship between input and output of a particular feature, but it can generate relationship between features also. So it is more advanced. It is actually recently modeled. So this is the difference between Monte Carlo simulation and multi-level Monte Carlo simulation. Okay, regarding the results of both of them, initial result we did a correlation analysis because we want to make sure that there is a relationship between the input and the output. So how to do this? We do correlation analysis. And if the correlation analysis results show positive values means that there is a positive relationship. If this variable increase, for example, here we have the ozone, then the API increase. Okay, so as you can see, all of them have positive values between 0 and +1. Okay, so all of them are relevant to calculate the API. Okay, this is the initial result. The prediction result, actually, as you can see, this part is the Monte Carlo simulation, and this part is the multi-level Monte Carlo simulation. And we have prediction of 1 day and the day 1 and day 2. Okay, day 1 and day 2, short term. From 1 to 5 considered short. If you predict weekly or monthly, it is long-term prediction. So based on the evaluation parameters, as you can see, we take the R square that shows the prediction accuracy. And you can see that in the first day, and these are the locations, 10 locations. In the first day prediction results, the multi-level Monte Carlo simulation is better. Okay, plus 1 or 2 the difference. Okay, and in day 2 also it is much better. The plus 3 or 4 the difference between Monte Carlo simulation and multi-level Monte Carlo simulation. And also the time, because the multi-level Monte Carlo simulation will work on parallel for all the attributes or features. So it is, runtime is very short. It is computational costly, of course, because it is running parallel. But nowadays we have very powerful computers, so it doesn't matter. Okay, so as you can see, the time also has reduced almost half. Okay, so based on this, and you can see here we have the overall calculation average. So Monte Carlo simulation has 86.45, and this is on average, and the Monte Carlo simulation is 82.90. The difference in accuracy almost 4%, and the time also it is almost reduced to half, meaning that the multi-level Monte Carlo simulation that we propose is a better prediction method for air pollution index. So in conclusion, in this work we propose multi-level Monte Carlo simulation Actually, the new thing in our project is this multi-level multi-color simulation is not implemented in air quality prediction or air pollution index prediction. So this is our modeling to this algorithm to do this task is our contribution. So we compare as a benchmark with MCS, and the results show that multi-level Monte Carlo simulation performed better than Monte Carlo simulation in terms of accuracy, error, and time. Our future work is applying machine learning. After we have the data from prediction, we can apply this data in classification because we have already the labels, class labels. So the future work is using machine learning to check their performance. Okay, that is all from me. Thank you very much. And if you have any questions from the floor or Dr. Gali.
Doctor, I'm Dr. TB, inshallah, under your leg. So thank you very much, Doctor, for the wonderful presentation. So, so the floor is for the audience, whether they can ask. So please try to ask because Doctor has a lot to say about this research work. So he will give us more input regarding to this research work. So please don't hesitate to ask, or don't shy to ask. Just ask. Me, I cannot ask, Doctor. Thank you very much, Doctor, for the wonderful presentation. God bless you.
That's all.
So thank you very much. So in the absence of question, I think we can move to the next presenter. So as I have seen, one of the author of our next presenter is present, right? Like Azira Aziz. Are you hearing us? Azira Aziz.
Yes, I'm here.
Already there? Yeah. So the FIFA ID is 43, right? 43, title Comparative Performance of Multi-Level Pre-trained Embedding on CNN LSTM and CNN LSTM for hate speech and offensive language detection. So as I have seen, you start sharing your slide. Okay. So the floor is for you. Present.
Can you hear my voice?
Yeah.
The screen?
The screen, okay.
Okay. So Assalamualaikum and good afternoon. My name is Azira and today I will present our paper entitled Comparative Performance of Multi-Level Pre-trained Embeddings on CNN LSTM and CNN LSTM for hate speech and offensive language detection. So as you can see, this is the outline of my presentation. We start with the introduction, architecture used in the study, experiment setup, results, and end with the discussion. So the first of all, I will start with the introduction part. So as you can see here, the majority of the existing works focus on the binary classification, which is to detect is either hate speech or non-hate speech. And some research focusing more on the various types of hate speech, for example, like cyber hate or like cyberbullying, racism, and so on. So unfortunately, based on the social media platforms such as Twitter or nowadays known as X, okay, and Facebook, they are not prohibited the slurs
or profane words, okay, in some situation, okay, as long as this word could be offensive to certain people, but not to the extent of inciting hate speech based on the words used in the sentence. So therefore, in order to uh, avoid, okay, to cause the overset limits, okay, of hate speech, so we actually focus on the trinary classification, which mean that we concatenate the hate speech and the offensive language. Okay, and then as we know that nowadays, recent years, most of the studies focusing more on the deep learning. So in details, there are two parts, right? In the first part is focusing on more on the deep learning itself, which we can use the neural architecture, like to automatically extract the multiple layers from the text encoding, and also we generate the feature representation vector. And then the next one, okay, the second part, it will attempts to train a layer to classify the text from the representation that we created from the first part. However, the issues of the deep learning base, okay, in hate speech and offensive language detected content, as you can see here, there is a limited study explores on the pre-trained embedding techniques. As we know that we have lots of pre-trained embedding techniques, okay, such as word to VTech, bird, glove, and so on, okay, to encode the text, and then. And most of the study in the for the they use, okay, the single neural architecture. For example, some of the existing works, okay, use only CNN or the LSTM. So in details, as you can see in the written works here, okay, some of them they adapted, let's say, the bird to detect the toxic of the Twitter dataset, and then some of them they use a glove or word to VTech, okay, with the LSTM or the CNN network to extract the features. So as a conclusion here, as you can see, okay, as I mentioned in the previous slide, so in overall, most of the study implementing only a single pre-trained embedding, okay, such as bird in this the first related works there, or CNN or LSTM are commonly used to distinguish hate speech from offensive language. So therefore, as a solution, our study because we know that we have so many types of the pre-trained embedding, and we also know that besides single neural architecture, we also can actually combine the CNN and STM, right, to become like multiple architecture of the deep learning method. So therefore, we want to investigate which pre-trained embedding is the best, okay, for each level. Let's say we have a few levels here, okay, in word, subword, and character to detect hate speech and also offensive language. And then we also investigated, okay, the best neural architecture network. So in this paper, we actually studied or we investigated on CNN, LSTM, and also CNN, LSTM. So and then the next one, I focus on the architecture, okay, used for this paper. So it contains, okay, for this work, okay, it contains three primary layers, as you can see. Okay, in figure here, we have three layers. Okay, the first layer from the text, we have the text embedding layer, and then followed by the representation layer, and the last one is the output layer. So as you can see, I will start with the text embedding layer here. So for the text embedding, we actually in this layer, okay, we encode the textual data into vectors. So for this study, okay, we actually use, okay, pre-trained text embedding. There are few of them. So there are two groups. Okay, for the first one is non-contextual. So the non-contextual contains of word to vector, glove, and fastag. And the next one for the contextual, okay, we use Elmo and the bird. So the reason why we use this text embedding, because we know that each of them has their own advantages and also disadvantages. So for example, right, for the non-contextual approach, okay, it can coverage the neural network, but however, of course, it contains the limitation which the contextual approach disregards the polysemy and resulting in unique representations for each token. So as for the contextual approach, okay, is slower, okay, compared to the non-contextual. Okay, but and then for in details, so as we know that for each pretend text embedding, of course, they have their own advantages and the limitations. So as you can see here on the screen, let's say for the word to betek, okay, it does not use the information, okay, in the whole document, okay, or the subword information there. So because of that, okay, it cannot discover the OOV or out of vocabulary terms. And also the next one in glove, let's say, okay, in glove it can solve the problem that cannot be solved by the verb to vetek there by learning the vectors of the character engrams or parts of the word. And then the same for the fast tag there, okay, it able to produce the embeddings or any misspelled words. So as you can see, especially for the social media content, so it contains a lot of misspelled words or uncommon words and so on. And so it is good actually we investigate how fast text can solve this problem. And then the next two, which are Elmo and Bird. Okay, this is for the contextual embedding. Which both actually, for example, like the Elmo, okay, it can capture context dependent, and also for the Bird is actually the most one of the most effective context and word representation. So as you can see here, based on the advantages and limitations, of course, they have their own features. They're able to extract the features based on their advantages. So therefore, it is good for us to investigate which pretend embedding is the best to identify the context, the hate speech, okay, and offensive language. Okay, the next one, besides the pretend embedding itself, we also will represent the text based on the different tokenization level. So as we know, for the word, okay, we use the word to vetek, glove, fast tag, and so on. And for the subword, we use glove, fast tag, and bird. And for the character, we use glove and fast tag. So for each of it, first we actually use the pretend embedding, okay, to obtain the fixed word. Let's say for the word level, and then the next time we will repeat, okay, the same, okay, for the subword and character level. And then in the next layer, as you can see here, okay, after we have the text embedding layer, we have the representation layer. So in this layer, okay, we considered three common network architecture types. Okay, as you can see, we use actually CNN, LSTM, and also CNN, LSTM. And the next layer, the last layer, okay, is actually the output layer. So it's actually to show the probability. And then next one, I will discuss, we explain the experimental setup we use for this study. So let's say here we divided our experiment into several parts, okay, based on the tokenization level and the model used. And we also use the same experimental setup, okay, for all text embedding and also the tokenization levels. So for example, the first architecture for CNN, okay, they contains 5 layers there. So we start for the input layer, whereby this is the layer we accept the embedding for all the tokenization level. Okay, and then we have the convolutional layers. So in this layer, we contains 3 convolutional layers, right, with the filters of varying size, such as 3 times 3, 4 times 4, and 5 times 5. We extract in this layer, extract the different local features from the text. And then we have the pooling layers. Okay, next followed by the fully connected layers. And then at this layer, we use the 2 fully connected layers, okay, following by the pooling layers before to interpret, okay, the features for classification. And the last one, we use the softmax output layer to classify the category. And then for the LSTM layers, so also contain 5 layers. Okay, the first one is for the input layers, and then followed by the LSTM layers. Okay, we actually to capture, we use this data to capture the dependency and the context within the sequence of words, let's say in a tweet. And then for the dropout layer, we actually use around 0.2 okay, to 0.5 to prevent any overfitting. And then for the fully connected layers, we actually use one or more dense layers with activation function value there, okay, to process the non-linear data processing. And then the last one, the same as the CNN, we also use the softmax output layer there. And then the next one, we have the CNN LSTM architecture. So this one also contains 5 layers, but for this part we actually combine the CNN, okay, followed by the LSTM layers there. So therefore for this architecture, they can extract the local features and also the dependency, long dependency between the features in the sentence. Okay, and then for the results and discussion, for this experiment, we actually use the data set, the well-known published by Davidson, which contains 3 classes there. The first one contains the hate speech tweets. Okay, the second class contains the offensive language tweets, and the last one is neither tweets. So as you can see, in this data set is an unbalanced data sets, right? And then we divided this data set into 70% for training and 30% for testing. And then as for the result, okay, we report our experiment based on the precision, recall, F1, and the accuracy. So for the result and discussion, as you can see in this table here, so for the character glove, okay, at the character level here, achieve for the CNN LSTM, achieve the best result among all the tested methods. So as you can see, the risk scores here is obtained about 93% for the F1, okay, and the 92% for the accuracy. And at the word level, the bird pre-embedding, we with the CNN LSTM obtain, okay, the best result or best scores of the 90% for F1 and also 91% for accuracy. And the subword label bird word embedding, okay, perform the best for both CNN or also CNN LSTM here with 86% score for accuracy and 86% for the F1 score. So as a conclusion here, okay, the results show each pretend embedding at different tokenization will capture a different information, and therefore it resulting in different result for the same neural network architecture at a different tokenization level. So therefore, as you can see here, CNM yield the best result compared to the CNN LSTM because we know that CNN and LSTM have the capacity to capture the temporal dependency and also the long range contextual insights, which is good because we know that hate speech contains really like ambiguous text. So as a conclusion here, this study investigated the best pretend text embedding for each tokenization level and identified the best neural network architecture as encoding method for hate speech and offensive language detection. So based on the accuracy results, so CNN LSTM is found to be the most effective, incorporating significant features such as glove fast tag at the word level, Elmo also at the word level, bird at the word level, and for the sub word level for the fast tag and bird, and the last one, the glove at the character level. So as for the future works, we can actually explore others neural architecture such as GAN or multi-layer perception, and we also can solve the issue of the imbalanced data set, even though it's hard because we know that most of the social media platform, they will automatically delete all the data or content. And then that's all for me. Thank you.
Okay, thank you, Mrs. Azira Aziz, for the wonderful presentation. So please, if you have any questions, so you can ask. The author is here for us. So thank you for the wonderful presentation. So this is the end of the session, but before we close it, please try to open your webcam for the photo session, please. So please, can you on your camera for photo session? Please, can you on your camera for photo session? Can you?
Where is everyone?
Okay. Can you
Wait,
open?
wait me. I am coming.
Yeah, I see, doctor. Welcome, doctor. We are waiting others to join. Yes. So thank you everyone. Thank you, doctor. Thank you. Have a nice day.
Thank you, Chairperson.
Thank you. Yeah. Mm.
Mr. Chi Lok Chua. Mr. Chi Lok Chua, are you there?
Yes.
Okay. Are you okay to present now? Because our early three papers, our authors are not in. So can you present first? Is it fine for you?
Okay, let me prepare first.
Okay, you prepare so that I can give opening note.
Okay.
Thank you. Thank you so much for your cooperation. Nazim, tepi. So, Assalamualaikum and good afternoon to our fellow researchers in the session. So I am Ashikin Ali. I'll be your session chair today. So we probably supposed to start with Vinodini Kasinathan, which is paper 049. But unfortunately, our 2 to 3 papers we have to skip as for now. So I am starting with Mr. Chi Lok Chua, paper ID 6, with the title of Minimal Data for Maximum Impact and an Indonesian part of speech tagging case study. So I would like to welcome Mr. Chi Lok Chua to present his paper. And thanks a lot for your cooperation for presenting earlier from your schedule. So you may begin now. Thank you, Mr. Chi.
Okay, thank you for introducing. So, good afternoon. My name is Chua Jilo. I'm a master's student for Thai UMT. My presentation title is here, Minimum Data for Maximum Impact and Indonesia Part of Speak Tagging Case Study. Our paper objective is to find a way that can effectively reduce the need for manual data labeling while preserving the model accuracy. This paper is related to NLP, and more precisely, this paper is related to one of the NLP tasks. It's called part of speech tagging. As we know that low resource language dataset always facing some problem and difficulty for developing in NLP. This is because we are difficult to find a good quality label data for low resource language, and some low resource language are even worse. You can't even find label data at all. And so what we can do to get the label data is do the data labeling manually. And however, this is troublesome as NLP data labeling require the one who labeling at least know the language. But if the NLP task is very difficult, such as machine translation, then we need to find the language expert. And this can be very expensive. And in addition, in order to gain high performance model, is needed to have a large amount of labor data. This also need quite long time to achieve, so it's time consuming. However, this kind of laboring burden problem is not a new problem. Current research have come up different solutions for this, and we conclude that the methods here are transfer learning, meta learning, semi-supervised learning, and data augmentation. And transfer learning is just aimed to improve learning performance or minimize data annotation need by transferring knowledge from similar domain. And meta learning is teach model to learn how to learn by training on a variety of tasks. It enables them to quickly adapt to new tasks with minimum data, improving efficiency and performance. And semi-supervised learning just combines supervised and unsupervised learning technique to enhance classification performance by leveraging both labeled and unlabeled data. And this approach can improve model performance when sufficient informative unlabeled data is available. And the last one is data augmentation, expand data set by correcting modified version of existing data or generating synthetic data. And in our paper, we choose semi-supervised learning as our method to train the part of string tagging model. And this is because other methods like transfer learning and meta learning are using the pre-trained model. And the problem of low resource learning is difficult to find label data. Then pre-trained model will be much more difficult to find. And however, some of the low resource learning is still able to find a large amount of unlabeled data easily as compared to find the pre-trained model. And another reason is semi-supervised learning is easier to implement as compared to other three methods. Here is the overall methodology used in our paper. So our NLP task is part of speech tagging. Our algorithm used is called semi-supervised learning. More precisely, is Theros encoding semi-supervised learning. And our target language used in this paper is Indonesia. So the training data used in here got two types, which are labeled data and unlabeled data. And because semi-supervised learning requires less labeled data, so we only using 520 words that extract for Indonesia GST universal dependency data set. And semi-supervised learning also requires large amount of unlabeled data, which in here we use around 400,000 sentences that extract from the Indonesia CC 100. And both sources can be obtained from internet easily, and both are free of charge. This is the workflow. First, we put the unlabeled data into this work clustering algorithm, which is brown clustering. And this brown clustering will generate this what we call browse product, which is a word representation in big string. And we then put this label data and this brown product together to do this what we call feature engineering. And this feature engineering will produce the feature. Then we will use this feature to train the classifier. And then at the end, the post-tagging model will be trained out. And what is brown clustering? So the use of brown clustering is just generate the lexical representation for individual words. And we believe that this lexical representation can capture through hidden state reflect part of speech tag. And the black box here is the example of the brown product that generated by the brown clustering. As you can see here, 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, and 1, 1, 1 are the big string. And each big string is represented as a lexical representation for their corresponding word. For example, the 0 is the 1, 0 is chase. And here is the feature set used in the feature engineering process. So the feature set's got a name, is called base. And this feature set is just used to capture the information of word and surrounding word. As you can see, the word itself, that's the word, first letter is uppercase, this kind of thing, and also the first next word, the first previous words, this kind of thing. So the total size of this feature set is 16. And this is another feature set which is called bit. This bit feature sets combined with the base feature. So the 16 feature will be added inside this bit feature. And the word representation information that generated by the broadcasting. Therefore, this feature set can be more than 100. Okay. And these are the classifier used for training to the part of speak tagging. So with our support vector machines, neon base, decision tree, k-nearest neighbor. And you can notice that these classifiers are not a popular way to train the part of speak tagging. The popular way are hidden Markov model, HMM, or conditional random field CRM. And the reason why we're using this classifier is the input of this classifier is word. However, HMM and CRM take one sentence as one input, which will require of the number of data increase. So we are using this traditional machine learning classifier. And in order to test our model, we prepare 11,000 label word which come from Indonesian GSD Universal Dependencies dataset to test our model. Accuracy, precision, F1 score, and recall is used to know how good that our model perform. So this table shows the result of 4 classifier. In order to know how good the model performance after include the word representation that generated by the brown clustering. And these 4 classifiers are just using this base feature only. So with the feature set that without include the word representation, and the number of label data here to use to train is 520 label word. And you can see here the result is not that bad, as every metrics here in every classifier are almost achieved 7%. And the best classifier is SVM, which can achieve 81% on precision, recall, F1 score, and also the accuracy. And this table shows the performance of classifier that using the bit feature and also using just 520 label word only. So by introduce the word representation that generated by the brown clustering, it really can improve the performance. For example, this SVM now become 84% in precision, recall, accuracy 83% in the F1 score, which improved about 2 to 3% as compared to only use the base feature. So in conclusion, we proved that Steros and Kotlin's algorithm is workable in Indonesia, as their original paper does not test their algorithm in Indonesia. And we also proved that their algorithm can also be used by other classifiers such as naive-based decision tree KNN, k-nearest neighbor, as their original paper only used the SVM only, even though our results also show that SVM is still the best one. So the future work is, because the way of training this post-tagging model using this research, it cannot be successful if the label data is low quality. Therefore, the future research direction should be finding a way to filter out which unlabeled data are worth to do the labeling from a large amount of unlabeled data. And that's all for my presentation. Thank you.
Thank you so much, Mr. Chong, for your presentation. So as for now, I open to the session. If you have any question to ask to Mr. Chua. if there is no question, then I would like to ask a question from you. So, since you talk on the part of speech tagging case study, like on Indonesian language, do you think that your model will be working in other speech tagging case study, or what would be your future idea, like any other languages? Like if you can elaborate. Thank you.
I think as long as your language is Latin script, just alphabet, and then separate the word by a space, then I think this can be applied. And this methodology not only for not only for this part of speech tagging only, also can be applied for name entity recognition. So as long as sequence labeling task, I think it can be held.
All right. So, thanks for your answer. And yeah, I believe like it's like obviously like we don't know like which works with which algo, right? So it could be a new try for you in future. Anyway, thanks and congratulations on the submission to SCDF and your cooperation on presenting the paper. Thank you so much, Mr. Chua. So next, I would like to ask Miss Nur Aida, my alumni clan. Are you there? If you're ready, I think we can proceed with you. We can't hear you. So I would like to invite Nur Aida Hussaini to present her paper entitled Predictive Modeling of Gold Prices, Integrating Technical Indicators for Enhanced Accuracy. So you may begin your presentation now. Thank you. We can't hear you. We cannot hear you. Okay, now. Okay, now we hear you. May I continue?
Okay, sure.
All right.
Okay, so hi everyone. Wait, Okay. Now my mouse cannot function. Wait,
It's okay, it's okay. You may set it properly before you begin.
Okay.
Is it okay?
So now can see and can you hear my voice?
Yes, we can.
Okay. Okay, so hi everyone. So today I would like to share my research title, Predictive Modeling of Gold Prices, Integrating Technical Indicators for Enhanced Accuracy. I am Nur Aida Hussaini from TAR UMT. So without further ado, let's move on to the next slide. So actually, this graph indicates the gold fixed price at 3 p.m. London time. So we have two lines available in this graph. So the first line is the green line. So the green line actually it shows the gold fixing price at 3 p.m. at the London bullion market. we call it as London gold fixing or London gold price. So actually, it is a pivotal benchmark used worldwide to determine the price of gold and also gold-related financial products. So this price is established twice daily. So one is at 10:30 a.m. and another one is at 3 p.m. London time. Okay, and then for the yellow line, also it indicates the trade weighted US dollar index, or we call it as broad index. So broad index actually it gauges the strength or weakness of the US dollar in the global market. So when we talk about the US dollar and also the gold fixing price, it always there's an inverse relationship between gold prices and also the value of the US dollar. For example, as the US dollar weakens, so gold prices tend to rise and vice versa. Okay, so actually gold prices are also influenced by various economic or business cycle. So for example, in 2016, so gold prices exhibit a downward trend. If you see here, we can see that there's a downward trend due to multiple factors. So, for example, it can be affected by global economic uncertainty. So, particularly within the European Union, or we call it as Brexit. So, for example, if I'm not mistaken, in June 2016, so the United Kingdom they decide to leave the Brexit. So this phenomena actually it leads to the uh, downward trend of the US dollar, and at the same time gold price start to increase. So in this phenomena, the traders they tend to they tend to buy gold as a safe haven asset. Okay, and then if we look at here also, in the end of 2019, to be exact, in December 2019, and throughout 2020, there's a fluctuation. There is increased trend in gold price during the pandemic. So from here, we can see that it is caused by the pandemic issues. So that's why so go back to our title. So in order to ensure that financial stability and to prevent market disruption, so we conducted this research to understand the fluctuations in gold prices, which actually can impact global financial market. Okay, so as we can see, gold prices actually it often viewed as an economic indicators that reflects broader economic trends. So, for example, rising gold prices may signal economic uncertainty or geopolitical instability. So, which later on it prompting investors to seek a safe haven asset. So, in order to address this issue, we implemented three uh, basic machine learning algorithms: decision tree regressor, support vector regressor, and also random forest. Okay, with proper parameter settings to ensure that the predicted values closely match the actual result. Okay, also we investigated the use of technical indicators um, to predict the fluctuation in the gold price, which later on with the hope so that it can impact the overall performance of the machine learning model. Okay, and then for the literature review, actually several studies have been conducted on gold price prediction using machine learning algorithms. So, for example, Leveris and colleagues they implemented the hybrid LSTM, long short-term memory, together with CNN, convolutional neural network, with the aim to predict the movement of the gold price market. Their findings shows that the combinations of LSTM together with an additional layer of CNN do increase the forecasting performance. And then for the second one, Growell and colleagues, they implemented the LSTM together with the STI. So STI is the stock technical indicators to predict the stock price. And then they created two applications. And then based on their findings, the daily prediction shows up to 68.45 accuracy and average accuracy of 61.51%. Okay, and then we have Ni and colleagues, Potoski, and not to forget Zhao and colleagues. They use machine learning together with technical indicators. So, for example, we have Bollinger Bands, trendliness, rate of change, stochastic oscillator, and so on. So they combine these technical indicators with machine learning, and then surprisingly, based on the result, based on their findings, it shows satisfactory and also acceptable accuracy rate. Okay, and then so this is the step-by-step process that we do for our experiment, for our research. So we have 6 phases. Starts from the data overview. So we use time series data set from Kaggle. So literally, this data set range between December 2011 until December 2018. Okay, so we do data analysis by using Python within Jupyter environment. So actually, this data set consists of plus minus around 1,700 instances and 81 features. So out of 80 features out of 80 columns. So there's one specific column titled adjusted close price. So this adjusted close price is our target variable, and then the remaining features or the remaining column is the input variables lah, or the input features. But somehow we are not going to use all the 80 features, because if we use all features, it will create a scenario that we call as curse of dimensionality, because of the high dimensional spaces. So the data point, it can become sparse, or meaning that the data is spread out and less dense. So if it is spread out and less dense, it will make it harder to find meaningful patterns, which later on the model actually it will struggle to find useful relationship in the data, and at the end it will decrease the accuracy rate. Okay, and then the next part is data pre-processing. So we perform 3 anomaly detection by considering 3 categories. So the first one is null data detection. So there is no missing values present in this time series data set. So this might due to careful and thorough data collections processes by the contributor of the data. And then for second one, duplicate data detection. So there is no duplicate records in the date column. Okay, and then for the outlier detection, there's no outliers. For outlier detection, we can say that there's a slightly increase in the terms of frequency outliers in June 2012. So if you get here, if you refer to table 1, so we have a lot of outliers. For example, in the 1st June 2012. So we observe exceptionally high fluctuations during the 1st June, where from here, this highly fluctuation is considered as outliers. But somehow we prefer to keep the outliers, because for the time series data set, as it consists of a lot of fluctuation, up and down fluctuation. we believe that these outliers, it can provide valuable insight because it always affected by certain extreme events like pandemic COVID-19, or it might be affected by the flood, or it might be affected by any event, any extreme event. So we choose to keep these outliers because we think that these outliers, it can carry a meaningful insight to the traders and to the financial market to predict the gold price in the future. Okay, and then for the next part is data selection. So data selection actually heavily depends on feature selection. So our aim is to choose a subset of input variables by eliminating those with little or no predictive values, with the aim to improve the model quality and making the modeling process more efficient. So in this part, we employ two popular feature selection techniques. So the first one is correlation coefficient, and then the second one is mutual information. For the correlation coefficient, we choose the value of R which is more than or equal to 0.7 for future considerations. So why we choose this value? Because it exhibits a significant linear association with the target, and changes in this feature are likely to have a notable impact on the target variation. And then for the mutual information, we calculate the mutual information between the target and also the features. Actually, mutual information is a good alternative to Pearson correlation coefficient because Pearson, it can only detect a linear relationship, but somehow for mutual information, it can detect any kind of relationship, non-linear, linear, and other kind of relationship. Okay, and then based on the value of mutual information, which is more than or equal to 0.7, so this is the features or variables that we choose lah. If you see here, I cannot use my mouse maybe because of the internet connections. So we have feature open, high, low, low, just close, and so on. So all of the coefficient correlation value is more than or equal to 0.7. Okay. So based on this value, based on the mutual information scores for each target feature, in table 2, we selected top 20% in table 3, which is equivalent to 32 features. So why we retain the 40% of the features? Because we believe that it will effectively reduce the data set's dimensionality, but at the same time, we still preserve a substantial amount of information. So that's why actually 40% is the standard approach lah that has been used by other researcher when they use to calculate the mutual information score. Okay, and then for data construction, okay, together with the time series data set that we download from Kaggle just now, we created new attributes by employing the technical indicators because we believe that these technical indicators will be beneficial for predicting the future prices. Okay, so we explore 3 technical indicators: relative strength index (RSI), Bollinger Bands upper and lower level, and also the third one is average directional index or ADX. Okay, and then for the data preparation phase, so actually it focus on step by step to prepare the data. So for your information, actually data preparation phase actually is a crucial role to guarantee the accuracy and also to guarantee the consistencies of the raw data before it undergoes processing and analysis. And at the same time, data preparation phase also helps us to ensure the validity of the result derived from analytics applications. Okay, we use in data preparation part, we cover 3 So the first one is data normalization. We use standard min-max scaling, where all features are transformed into the range of 0 and 1. So which means the minimum and also the maximum values of a feature or variable are going to be 0 and 1 respectively. And then for the hyperparameter tuning, we use grid search CV to search for the best working hyperparameters to improve the model performance. And then for the training test split, because it involves time series analysis, so we assume that the previous values of the target or variables play a role to predict the future values. So we shift the target variable by 1 day to ensure that the predictor values are correctly aligned with the target variable. So in this case, for the training set, we use 1,347 instances, rows, and the remaining we use it as the testing set lah. Okay, and then for the next part is modeling part. So for modeling part, we apply decision tree regression, support vector machine or support vector regressor, and the third one is a random forest. Okay, so why we use decision tree? Because it is straightforward to interpret and understand. And then in terms of implementation, they are easy and minimal need for hyperparameter tuning. Okay, and then for the support vector machine or support vector regressor, because it excels in high dimensional spaces, and it also can capture the non-linearity within the data. Okay, and then for the random forest, so actually it can manage a large data set, and it can also capable to deliver highly accurate prediction. So that is the reason why we use this decision tree, support vector regressor, and also random forest to be applied together with the technical indicator. Okay, and then the result section. Okay, so we employ, just now I mentioned that we employ 3 technical indicators, which are RSI, Bollinger Bands, upper and lower level, and also ADX. So actually, what is a technical indicator? So technical indicators is a tool. It is a tool used by traders and also investors to analyze past price movement and to predict future trends in financial market. Okay, so even though we have so many time series data set, but somehow technical indicators is specifically used for financial time series data set. Okay, so actually these indicators are usually based on mathematical calculations using time series data, just like I mentioned to you just now, using time series data like time, price, volume, or open interest lah. So this kind of technical indicators actually it helps traders or the investor to make decision about when to buy or when to sell the assets by identifying patterns, trends, and also potential signals in the market. Okay, and then the first technical indicator that we use is a relative strength index or RSI. So for the RSI, actually, it assesses whether a security prices is overpriced or undervalued by calculating. Wait, okay, sorry. RSI assess whether a security price is overpriced or undervalued by calculating the speed and magnitude of the recent price fluctuation. So give me more time to present my result. Okay, so it was introduced in a stepwise manner together with these 2 equations. So the first one is a relative strength equation, and then the second one is relative strength index equation. So by applying these 2 equation, we come towards the line chart in figure 1. So this line chart in figure 1 is a line chart of RSI. So if you get here, if the RSI value is more than 70, it's indicate that the gold may be overbought, but somehow if it is less than 30, so it indicates that it is oversold. Okay, and then for the next technical indicators, we have BB. So actually BB consists of a middle band of signal, simple moving average, and two outer bands set as the standard deviation. So we have two outer band, which is upper bound, upper BB, and also lower BB. So from this figure 2, you can see that the red lines indicates the upper band, and then the blue lines, the light blue line indicates the lower band. So before we use BB, so we need to understand several considerations. So for example, narrow bands indicates potential price breakout. Either the price touching the upper bands may signal overbought condition or oversold condition, and so on lah. So from here you can see the movement, and it decreased over time up until 2013. And also you can see another movement here, start from 2015 until 2016 as well. Okay, and then for the next technical indicator, we have ADX. So ADX is to measure if the price is trending strongly. So it involves the calculations of several components. So for example, we have positive directional movement, negative directional movement, true range, positive directional index, and also negative directional index. If the previous high or up move is greater than the previous low, the positive directional movement is equal to the up move, and negative directional movement is set to 0, and vice versa lah. So this is the findings, the line chart of ADX. So we can see movement at the end of 2013 and also in the early of 2016. Okay, and then for the overall performance, we assess the models to determine which one exhibit the highest predictive performance lah. So we use MAPE, we use R squared, RMSE, and also MAE. So speaking about the MAPE, so small MAPE, which is less than 10%, actually it indicates a high level of accuracy. But somehow, if the value is more than 20%, so it indicates the prediction error, which is the model is less reliable. But somehow, for our result, our MAPE percentage is in the range of is less than 10%. So it shows good and can be considered as very accurate for the DTR. And then for the SVR, for the R squared, so we choose the highest one. For the RMSA, we choose the lowest one, which is by SVR. And then for the MAE, means absolute error, the lowest one is by SVR. Okay, and then for the conclusion and improvement, so out of these three standard machine learning models, SVR, support vector regressor, outperform with the MAPE value of 0.490%, which it demonstrated a value which is less than 1%. And also in terms of accuracy rate, it exceeds 80%. And then after that, we implemented the SVR with technical indicators, and then we found that this combination actually it facilitates the identification of trends and possible market turning points. And we hope it can discern patterns in gold price movement. And at the end, it will assist the investors to identify, to determine whether the market is trending upward, downward, or sideways. And then for the future research, we hope to include experimenting with more sophisticated machine learning algorithms or assemble approach like deep learning techniques and so on to catch intricate patterns that a typical machine learning model would overlook. So apart from that, we also want to investigate the sentiment analysis of financial news or goal-related social media data with the hope to increase the prediction accuracy. And then we would like to thank University Tun Hussein of Malaysia to support this research. And then list of reference. So thank you. So if you have anything to ask, you can email me. So this is my email lah. Yeah. Thank you.
Thank you so much, Nur Aida, for your brief presentation. I have a question here from our fellow researcher. She asked you, like, may I know, is there any specific DL techniques for your future direction, or you plan to apply the method on other prediction other than goal related? The question is by Miss Yap Liu. So
At the moment, I want to try with the standard deep learning. I plan to use standard deep learning first lah, before going further to any advanced variant of deep learning. And then the second one is what?
You apply the method on other prediction other than goal related, maybe domain. I think maybe different domain. I think it's like your new domain at the moment. We have the question on the chat area. The question is like, okay, DL technique, or you plan to apply the method on other prediction other than goal related.
Wait, I cannot use my mouse.
Oh,
because it hang.
So the first question is like on the technique related, and the second one is on the domain. Like, do you have any idea of using different domain other than gold prices? That's what the question is about.
Maybe for future work, but at this moment, because my area is more to time series, maybe I want to try on weather data set, like the air temperature, humidity, rainfall, distribution data set, and so on lah, to predict the extreme level, maybe like flash flood and so on.
All right. So, yeah, was it fruitful? The
Yes,
answer
thank
from
you.
Nur Aida. All right, thank you. But somehow this is very interesting. So in future we can predict the gold prices. Like for the hiking price right now, we will be having a better predictive analysis for our gold prices. Anyway, thank you so much for your brief presentation, and we are happy that you cooperated and contributed to our SCDM. Thank you so much. So I would like to invite Keng Hong Eng. Are you ready for your presentation?
Yeah, I'm ready. Just a quick test here. Can you hear my voice?
Yes, we can hear you. So I would like to invite you to
thank
present
you.
your paper entitled Evaluating Pathfinding Algorithm for Real-Time Route Recommendation System Built Using Free RTOS. So you may begin your presentation now. Thank you so much.
Okay, thank you.
Okay, before Keng begin, hold on, Keng. Before you begin, I would like to request the presenters who have presented or will be presenting to remain in the session. That we will be having a photo session once we end the session. So thank you so much.
Okay, let me start my presentation. Okay. Can you see my screen?
Yes, can.
Okay, thank you. Okay, good afternoon to the session chair and everyone. Okay, today I'm going to present a paper named Evaluating Pathfinding Algorithm for Real-Time Route Recommendation System using FreeRTOS. Right, so this is actually a work done by one of my FYP students. Okay, first let me introduce myself. My name is Ng King Hong. So currently I'm attached to the Department of Computing at Utah. Okay, let me start my presentation with a brief intro or brief introduction on the problem domain, which is on the traffic side. Okay, so I believe everyone knows that, right? The world population is experiencing exponential growth, right? So as the population increase, right, so we can expect the number of vehicles, right, also rise. Okay, hence the traffic congestion problem, right, has been intensified in most of the countries, right, especially in metropolitan area, which has high density of populations, okay, such as in Klang Valley, right, Malaysia. Okay, so that's why this remain as a very interesting topic. So many urban motorists daily, right, as well as their overall well-being are seriously impacted by these traffic congestion problems. Okay, so in addition, the prolonged period of traffic condition is also one of the main cause, right, to problems such as environmental pollution, particularly in urban areas. Also, motorist mental health, such as stress and frustration, and also reduced productivity, right? Because employee may be late for work, right, due to traffic jam. So hence, the main objective of this project is to develop a simulated real-time, right, route recommendation system using the open source FreeRTOS, which is a secure, free, and lightweight real-time operating systems. It also aims to ease the transportation concern by providing more efficient travel options, indirectly increasing user satisfaction as well as reducing the current urban traffic congestions. So it means that the system shall recommend the best route between the 44 shopping malls in Klang Valley for urban motorists. So we use the 44 shopping malls in Klang Valley for our testing. So next, we look at the functional diagram of the simulated systems. So basically, right, so four key tasks or four main tasks are identified as the component in the systems. So they are, first is the user query generation task, so which is used to generate a random number of user queries with varying sources and destinations. So this task shall send multiple source and destination data to the query queue, and then this will be processed by the path calculation task. Okay, so the second task is the path calculation task. So this task will employ Dijkstra algorithms or A-star algorithms to recommend the shortest route back to the motorist. So these algorithms rely on the initialized or updated cost metrics in the average traveling time matrix table. So the third task will be the motorist data generation task. So this task is in fact used to simulate motorist speed data. So it generates motorist random path and speed data into batches. So it means in every batch, it can hold up to 5,000, right? 5,000 motorist data, and then this data will be sent to the, to this motorist speed queue, and then to be processed by this matrices update periodic task. So the fourth one should be the matrices update periodic task. So this task will update the matrix table periodically, right? So, and the matrix update periodic task will only be performed the updating actions when it's activated at predetermined interval and acquire the mutex. So in this one here, right? So the mutex will be shared among the two tasks. So the two tasks are path calculation task and the matrix update periodic task. So it means, they cannot work concurrently, right? Okay, so it means when this one of the tasks is working, so it means the other task should be refrained, right? Restrained from, and let's say to updating the task. Okay. So this one will be the four tasks that I explained just now.
Kang, I'm sorry to interrupt you. Can you switch on your camera if possible?
No, because of the band, I can switch on the camera after the presentation. Will that be okay? Because I'm using the mobile.
Oh, okay.
Will that be possible?
Yeah. Once you finish that, maybe during the Q&A,
I can switch on because
for a while.
if I turn on the camera concurrently, so it means that it will means the bandwidth will be affected.
Okay, no problem. You continue your presentation.
Okay. Yeah. Okay. So I'll continue with presentation. So this slide will describe, right? So we'll describe the data structure used in this simulated system. right? So of course, so we will use the adjacency matrix, okay, for the, let's say, for storing the data. So we apply the weighted directed adjacency matrix to store the data of shopping malls and the routes between the shopping malls, right? This is because it is efficient to check the connectivity, right, between the, let's say, between the shopping malls within big O1 time, right, which is really fast. Okay, so the three adjacency metrics, right, that are created in the simulated system, they are the distance matrix, then followed by the average speed matrix, and then the average traveling time matrix. Okay, so the first one, distance matrix, so it's actually represent the direct distance between each pair of nodes, right? So the nodes in this case refer to the shopping mall, right, in the graph. Okay, so the second one is the average speed matrix. So this one represents the average travel speed between a node pair, right? Or let's say a pair of shopping malls. So the third one should be the average traveling time matrix. So this one represents the average time taken to travel between a pair of nodes. Okay, so we move to the first one, right? So the distance matrix or distance adjacency matrix. Okay, so this table shows the connection and distance between the 44 shopping malls in Klang Valley of Malaysia. So the distances were collected through Google Maps. Okay, we collected this distance from Google Maps, and then the distance between a pair of nodes are stored asymmetrically. So which means that you can refer to this figure here. You can see that the distance, right, from AMTM to BSC, right? AMTM, you can see here, AMTM to BSC is 13. And then from BSC, okay, you can see BSC to AMTM is 11.2. So it means that the distance, in fact, they are asymmetrical. Okay, so we move on. Okay, we move on to the second matrix, which is the average traveling speed matrix. So this one represents the average traveling speed between each pair of nodes. So each cell will hold the structure of the speed route underscore T, this, right, this data structure. So in this data structure, it will store the three data attributes, including the path count, which is C, and then the average, the speed, and also the, that will be the accumulative speed, S, and then the average speeds. Okay, so it means that we can get the average speed, right, by dividing the accumulated speed of motorists with the number of motorists on the current path, right? So this is how we get the average speed. So it means we divide the accumulated speed of motorists. So if we have 5,000 motorists on the current path, and then of course we accumulate the speed and then we divide by 5,000. So this is how we get the average speed. So for this current path. Okay, so we move to the third matrix table. So the third matrix table is the average traveling time matrix. So this matrix represents the average time taken to travel between each pair of nodes. So it will act as a cost matrix, right, in the graph, so which enable the algorithm to find the shortest path or the shortest route. Okay, so it means that the Dijkstra or A star will compute the shortest path based on the cost metric on this matrix table. Okay, it will not based on the shortest distance, it will based on the shortest time taken to travel from one point to another. Okay, so it means it will be calculated by the average traveling speed, right? So yeah, in this case here, okay, so the average speed, right, is actually calculated by dividing the accumulated speed of motorists with the number of motorists of the current path. Okay, so we move next to the shortest path finding algorithms. Okay, so in this project, we adopted, right, the Dijkstra and also the A star as the shortest path finding algorithm to search for a shortest route to the shopping mall. So Dijkstra was chosen due to its widely used in solving single source shortest path problem in graph with non-negative, right, non-negative edge weights. And also, right, so A star is good at finding the most efficient route connecting two connections or two locations within a network of roadways. So in fact, it's quite similar to Dijkstra, but in A star, right, it used another function called heuristic to estimate the cost of the cheapest path from source to destination, right? So it means it has additional function called heuristics. Okay, so we move on to the result and discussion part. So firstly, right, so we have to verify the accuracy of the recommended shortest path or shortest route computed by the simulated systems. So the below figure, right, shows an example, let's say for example, for the shortest route verifications. Okay, as you can see, right, or as you can observe, right, the recommended route from, let's say from Lotus Kepong, LK, right, to Inch KL Eco City, IKEC. So you can see that the system suggested the path, right, include the passing by the Globe Damansara Shopping Mall, GDSM, okay, which is, in fact, the time taken will be shorter than the direct path from LK to IKEC. Okay, so it means that, yeah, the shortest path algorithm is working correctly, right? Even though, yeah, you can see the distance, right? Okay, the distance for the direct path is shorter, but the time taken is longer. Okay, time taken, the ETS is longer than the recommended path. So it means, yes, our algorithm is working, right? So it's recommend the shortest traveling time, right, from the source to the destination. Okay, so we move on next, right? So next we evaluate the real-time performance of the simulated system. So this table 1, right, in fact shows the time performance of the simulated system using this standard Dijkstra. System responded very quickly, right? Let's say to 100K, right? You can see from 100K user queries, right? So with the elapsed times of 0.026 milliseconds, right? 0.02 times milliseconds, let's say for 100 queries, okay? 100,000 queries, okay? So the average elapsed time for the 3 algorithms, right, did not escalate significantly with the increment of user query, right? We can say that here, right? So, and all responses can be delivered in real time. Okay, so this can be attributed to the parallel processing done in the FreeRTOS, which is an open source real-time operating systems. Okay, and then because of FreeRTOS, they can do multitasking. Okay, and then it can quickly switch among the tasks. Okay. So last, we tested the pathfinding algorithm's limit, okay, on the number of queries, of the number of user queries that it can handle concurrently, right? Let's say in this FreeRTOS environment. Okay, so as you can observe, right, from the bar chart below, right, so the number of user queries that could be handled by Dijkstra. Okay, let's say in this case using the priority queue, and the A-star algorithm picks as about 828K and 827K respectively. Okay, but if you look at the Dijkstra standard, right, so it could handle easily above 1 million queries. Okay, so yeah, I will conclude, right? So the work, right, with this conclusion. Okay, so I will just summarize the work. So this study developed a real-time route recommendation system for shopping mall in Klang Valley of Malaysia. Okay, so it is implemented using the open source, right, the FreeRTOS in simulated mode, right? So the result or the preliminary result show that the system can process large amount of user queries in real-time manner. Okay, so based on the 100K user queries, the fastest elapsed time is 0.026 milliseconds, right? So when it's implemented using the standard Dijkstra algorithms. Okay, so this study, right, in fact demonstrate a simple intelligent transportation system that can be implemented using the FreeRTOS with limited resources. Okay, so with this, you wrap up my presentation, right, for this work here. Okay, so thank you. Okay, let me stop my sharing.
Thank you so much, Keng Hong Ng, for your nice presentation regarding the pathfinding algorithm. It was interesting.
Okay, let me stop my camera, right? Okay, just yeah. Okay, yeah.
So like I open to the floor if you have any
This is me, lah.
If you have a question to Mr. Keng Hong Ng regarding his paper or the presentation just now. So looks like we don't have any. So we are your interesting research is like so good on this project. Like we believe like in future you might work on like more complicated areas in maybe whole Malaysia or somewhere like for your future work with your students or your postgraduate students. So anyway, thanks a lot for your fruitful presentation.
Okay, thank you for the
Alright.
session share. Okay, thank you. Sorry for any inconvenience caused, right? Because yeah, in fact today I have a tight schedule. I have two classes at the afternoon. Sorry about this.
Oh, okay, no problem. We understood. So thank you so much.
Okay, thank you. Okay.
Right, so next,
Okay,
I
thank
would
you.
like to invite Pravindran. Are you ready for the presentation?
Yes, can
Okay,
you hear me? Can you
you
hear
may
me?
present your paper entitled Comparative Study on Ant Colony Algorithm and Genetic Algorithm for Mobile Robot Planning. So you may begin your presentation. Thank you.
Can see my screen?
Yes, Ken. Can you switch on your camera while
Oh
you
yeah,
present?
okay, wait, hold on.
All right.
Okay. Okay, let me start. Okay, good afternoon, everyone. Okay, thank you for joining me today. Okay, myself is Pravindran Rajendran and my co-author is Dr. Maini Binti Othman. And I'm here to present my research on comparative study on ant colony algorithm and genetic algorithm for mobile robot planning. So let's begin with the research overview. The growing complexity of warehouse operation, especially in automated environment, demands advanced optimization techniques for managing the routes of robotic vehicle. In this study, just focusing on routing optimization. So the study evaluate ant colony optimization and genetic algorithm in mobile robot planning. So let's move to the problem statement. So the problem at the core of the research is how to optimize the routing robotic vehicle in automated warehouse setting. As warehouse become increasingly automated, the efficiency of those robotic system directly impact the overall operational performance. So they are key of the problems, which is in challenging in routing optimization, task scheduling and allocation, and also complexity in part planning. So this research seek to develop an optimization approach that can handle this complexity, ensuring the warehouse operate as efficiently as possible in implementing the both algorithm, ant colony algorithm and genetic algorithm. So basically, there are three main objectives, which is to investigate the ant colony algorithm and genetic algorithm features in mobile crane planning. And the second one is to implement the SEO and GA algorithm for solving the routing problem using the dataset collection. And the last objective is to evaluate and compare the performance of the SEO and GA algorithm in terms of optimizing the routing of robotic vehicles. Okay, let's discuss with the previous related works from the other research on the ant colony algorithm. So there are two papers. So the first paper, which is focused on the application SEO to the real world vehicle routing problem, which is VRP, and it also discussed various variants of VRP, including those with the time window, pickup and deliver, and online VRP scenarios. So basically, the evaluation of the technique showed that ACO is effective in solving different VRP variants and has significant potential for the real-world application in logistic and transportation field. So the main research highlight of this paper is highlighted of the efficiency of the ACO in solving different variant of the vehicle routing problem and emphasize the potential in real-world application. So move to the second paper. This is provide the thorough analysis of the automated lift planning techniques for the mobile crane, highlighting the complexity and dynamic of building sites that make women planning difficulties. So the review emphasized the potential of ACO in addressing the complexity of construction site and improvising the efficiency and safety of using the mobile crane lifting operation. So next, I move to the related works using the genetic algorithm. So the first paper proposed GA-based optimization method for mobile crane repositioning route planning, which is ALPOS. It represents a mathematical model that transforms construction location, identify a near global optimal solution for crane replacement, and determine the place point sequence using GA and Dijkstra algorithm. So the primary goal of this research is to minimize the total operating time required for the lifting work of a mobile crane. So the study proposed ALPOS as a methodology to minimize the total operating time required for the lifting work of the mobile crane. So the second paper is summarized, provide a comprehensive evaluation of part planning technique for AGV system, which highlighting the superiority of proposed genetic algorithm, especially the modified version. It states that the modified genetic algorithm outperform the traditional genetic algorithm, especially as the scale of the problem increases. Okay, now I touch down on the both algorithm. Basically, what they are. So basically, genetic algorithm is a natural selection and genetics, which are using the chromosome mechanism, natural selection, which is best solution for the chosen, and the second one is crossover for combining parts of two solutions to create new one, and the third one is mutation, that introducing variation to avoid local minimum. So for the genetic algorithm strengths are those that is strong global search capability that highly lead to various problem types. So the ant colony algorithm is basically a bio-inspired algorithm that mimics of the behavior of ant searching for food. So it translates its behavior into a method for finding optimal path through a warehouse. So the algorithm interactively improves solution by favoring routes with higher pure femina level, which correspond to more efficient paths discovered in previous situation. So ant colony algorithm strengths are which are highly effective for path finding and compensatory optimization. So now I move to the methodology. So this is our research framework. So the first one is to identify the optimization goal and then select the optimization algorithm, which are ACO and GA, and map both algorithm features to mobile crane planning, then adapt the algorithm to warehouse requirements and select the case study. Once select the case study, customize the algorithm for both case study, then integrate of the culture algorithm inspired by strategy, then evaluate the metrics and execute an iterative optimization. Okay, now I move to the algorithm implementation part. Basically, this both algorithm was implemented using the Python code in Spider. So these are the libraries we use for the both algorithm separately. So this is the evaluation metric we use. There are two. One is distance efficiency and time efficiency. So for the distance efficiency, it's basically minimize the total distance traveled by the robotic vehicle, as shown the formula below, that it measures the spectral efficiency of routes by summing the distance between the nodes in the optimized route. So the lower the best will be the best indicate to show the better efficiency. While for the time efficiency, it minimizes the time taken to complete the assigned task, and it evaluates the efficiency of the ACO and GA in optimizing both distance and time, that it will help in selecting the most effective algorithm for warehouse optimization by considering both spectral and temporal optimization. Okay, now I move to the result and discussion part. So the result of this study were quite revealing, as the ACO and colony algorithm constantly found the shortest route in less time compared to the GA algorithm, especially in the scenario where the environment was static. However, GA showed greater adaptability in dynamic environments, where the routes needed to be recalculated frequently due to the changes in the task assignment or on the obstacles. As shown in the table below, the ACO demonstrates superior performance in both case study 1 and case study 2, with the best distance and the best time taken, execution time taken. So we also did compare the average for the both distance and execution time many times running using the spider code. So from the distance comparison average, the performance of the ACO and G algorithm were observed. The analysis is based on the average result obtained through the multiple runs using the data set we have collected. So the below is on the execution time. The reported average execution time, our standard deviation captured the trend, the variation observed across the multiple runs. The average execution time for both algorithms in each case study are below. Okay, as a conclusion, this study was conducted with the idea of implementing the both algorithm, ACO and GA, in routing robotic vehicle to compare the performance in terms of distance and execution time. The algorithm used for GA and ACO, in which implemented in two different case study, which is case study 1 is from the conveyor position to the crane position, and the second case study is from the conveyor to the monorail, which we call AMS trolley. The result will compare. In conclusion, the performance of an ACO algorithm proved more suitable for optimizing the given automated warehouse in both case study, leveraging the performina trails and the probabilistic decision-making process. The ACO effectively navigated and covered toward routes with shorter distance compared to the genetic algorithm. So basically, the lower best distance achieved by the ACO implicate the significant time and the resources saving, enhancing the overall productivity and throughput in automated warehouse. Nevertheless, it is critical to consider other factors, including specific requirement, constraint, and computational resource when selecting the optimal algorithm. For the further experimentation and analysis under varied scenarios are recommended to ensure a well-informed decision regarding the most suitable optimization approach for the specific automated warehouse scenario. Okay, that's all from me. Thank you.
Thank you so much, Pravindan, for your presentation. So before we go to the next, I open to the floor on question and Q&A session. If you have any question to ask from the presenter. Anyone? If there is no question, then I would like to ask actually. Okay, in this paper, you have make a comparative study on ACO and GA, right?
Yeah.
So which is the core focus of your study actually? I mean, like this is like on comparative basis. So like are you like will be using from the finding we understood that ACO is better than the GA, right? So what was the core? Is it like you want a hybrid, or it's like you will be working independently on one optimization technique, something like that? Like that's the answer that I would like to know.
Basically, this I want to ensure to reduce the travel time and find the best route for the traveling the product using the robotic vehicle.
Okay.
So by implementing the better algorithm.
I see. So it's like, so this comparative study is like to actually to ensure you to select which is best for
Yeah,
your.
best.
Okay. So, all right. Thank you so much for your presentation.
Thank you.
Okay. Next presenter would be Pei Chun Lin, but unfortunately we couldn't find them in the session. So we will be actually playing their pre-recorded video, presentation video. So we will be proceeding in a while. Before our last presenter present their paper, which is Zhu Xin Lian. So you are ready, right, Zhu Xin? Once we finish with the pre-recorded video, we will be I will invite you to present your paper. Thank you so much.
Good afternoon, everyone. I'm Pei Jin Lin. I'm from Taiwan Fengjia University. Today, I want to present a topic about enhanced air quality index prediction using a hybrid convolution network. In this topic, I will introduce you my introduction and the related words. And also I will introduce you experience method and experience result and discussion and my conclusion and future work. So why I am doing this topic? Because in recent years the air condition is not such good, and usually when we see the future report, we cannot really understand what kind of air condition today. So we also don't know how to pretend this bad air condition. So I want to create some system. This system can predict the air condition well, and also can tell people how to prevent air pollution by themselves. So in this paper, I present a model. It is use graph convolution network and the temporal convolution network. Use these two network model to forecast the AQI. The AQI is air quality indicator. So we use these two models to forecast air condition and tell people how to prevent the air pollution. So why we chose these two models? Because we think that the air condition will affect by location. So different location will have different air pollution. So maybe nearby city will affect each other. So we think the location is also need to consider in in forecast air pollution. So in order to consider the location within the graphic network model is suitable to use in this place. So the air pollution also has data is considered about the time. So we also need to consider the temperature in each time for the air pollution. So we can, in order to consider temporal and spatial correlation shape to forecast the air condition, we consider these two models. So while we use these two models, we can go back to see the previous research work. We can see that usually people use ARIMA model to forecast the air condition. Also, they use the LSTM model to forecast the air quality index, but few people use GCM model and the TCM model. So for ARIMA model, it usually used for linear and unvaried time series data, and the LSTM used for long-term dependence and complete patterns for the sequential data, but it will also have some disadvantages, such as if your data is not linear and your data is overfitting, so it will become some problem in the forecast the future situation. So we consider the GCN. Of course, this G is considered the graph. It means that we consider the location problem in our research work, and also that we consider the TCM model. It is used to consider the time and long-term dependence data set. So we consider these two models to forecast the AQI. So how to do in this forecast? First, we get the data from our government report. The government report has many kinds of data. This data consider has site name, the country, AQI data creation date, longitude, latitude, status, SO2, etc. So has many kind of data, but we want to consider the location and the time problem to embed the AQI and forecast the AQI. So we chose 6 data in our data set. This 6 data is site name, country, AQI data creation date, and the longitude, latitude, the location. So these 6 data we use in our data set, and then we start to find the future we need to in the GCN and the TCM model. In GCN model, we need to consider the location. So we use latitude and longitude data for the GCM model. And in TCM model, we need to consider the time. So we use the AQI relation with time into the TCM model. And then we need to find out these two data, how to put into the GCN and the TCM model. So the data need to deal with a preparation, because the data sometimes is not such well data. We need to check out AV data, download data in AV time. So we first chose the data from February to January is 1 year data. 1 year data, but in this 1 year data, maybe we lost some data in some location. So we need to do pre-data analysis first. So how to deal with the lost data problem? First of all, we can see the table 1. In table 1, I shows one location, and this location loads some data in the some time. This data detect is one time will show one AQI data. This is from government data set. So we get this data, and inside the data has many different places and load some data. So if we lose data, we used into the model, it will lose some information. So we need to deal with the data first. We hope here has some data, and the data is not such different from previous or later. So how to calculate this data? This data we will calculate the previous two data mean. So we calculate mean for this data and choose the integral data. So here we chose 110. And after that, we calculate this data. This data we load some information. So this data we will use this formula. This formula to calculate this data, and this data is 110 plus 103. Choose its mean. So we have this data and this data. Then we fill of all data. We don't have any data set is lost data information. And after we pre-calculate the data set, we collect all data into our model, to calculate the model feature matrix. So how to calculate out the feature matrix? As I said before, we need to calculate two models. One model is calculate graph convolution network, and the other model is calculate the temporal convolution network model. So these two models need to consider two information. One information is consider the location. So the location we will use the latitude and longitude data. This is for some city data, and we just show some city data. And after we calculate, this is from the data set, and then we need to calculate the model need feature. So the model we will calculate the nearby situation, and we use the adjoint matrix to calculate nearby situation. So this matrix will use in GCM model. So how to calculate it? We use the distance formula to calculate it. So we put into the table 3 data into here, and then we calculate the distance between the observed station. And then after this, we still need to consider the adjacent matrix. So we calculate the other web. This web of this term will calculate all this matrix. So this is the feature we need in our model. Okay, so we need the first GCM model. We have calculated the matrix. The second model is TCM model. This model considers the time. So time series data to calculate it, and then we need to calculate the input data each by each, and we also need to calculate the temporal convolution network. So we calculate the AQI data in this model. AQI data also consider the time problem. So in this model, the point between each other is used exponentially by a factor of 2. So here is calculate the relation, and we have the residue connection here, and then output our matrix. So our matrix is from the AQI data. This is calculated from our previous data analysis. So we all fill out the empty data. Our data no loss data. So here we have two model net matrix, and then we put these two matrix into the model. These two model has our future matrix, and then we output our prediction results. This is AQI prediction result. So our prediction will use different data sets about based on different time. First, we use 1 year data set to forecast the next 1 month, and the second, we also use half year data set to forecast the next 1 month or half month. And then we also use seasonal data set to forecast the next 1/2 month. So in this situation, we do many experiments analysis. So from this result, we can see our figure here. This is the best result we got. This result is from the data from February to July. Is half year data to forecast half a month data set. So we can see that we get more, this is our model, we get more less MAE and RMSE. So we have the best result during the period here, and forecast the more better result here. So consider other model, we also calculate the same data set, we get different result. You can see that the TGCN and the GRU and the GCN in fact is not such bad, it's similar, but our model, it can get the most best result here. So in the future, I think that we use this data set, we use this model, we can use different data set to tell people the next month's air pollution situation by AQI information. So how to tell people how the forecast AQI result? We hope that we can do some system like we can use form and location, get location data, and then we can use history data and use our model to forecast the AQI data and tell people today's air pollution situation. So for example, we can circle data location by color to show different air pollution situation. If air pollution is more serious, then it's red color. If the air pollution is good, then it's this color. So people also can use the color to see your city, how the situation of your
Hello everyone, my name is Zhu Qing Lian. I'm the first author of our project, and our project is test sentiment analysis on VIS impact on market sentiment dynamics. Here is the abstract of our project. This paper examines the impact of the US VIX on the sentiment of Chinese investors. And the US VIX is the volatility index
Sorry for
for the
interruption.
United States.
My video.
Neglected
Zushin, you are
related
alive, right?
to
Hold
storm
on, hold on.
Yeah,
I'll
yeah.
do the technical thing.
Xinlan Weibo from 2019 to 2023 and classify all comments using
Hold on here.
Ada. So sorry for the inconvenience just now.
Yeah.
The technical team thought you are not around in the session, so I would like to invite you for your presentation. So
Okay.
you'll be the last presenter for our session today. So
Okay.
you may begin with the presentation. Thank you so much, Zushin.
Okay, can you see my slide?
Yes, we can. Okay, it's working.
All right.
Okay.
Let's start. My name is Zhu Xinlian, and I am the first author of our project. And the title of our project is Test Sentiment Analysis on VS Impact on Market Sentiment Dynamics. Here is the abstract of our project. And this paper examines the impact of the US VX, which is the volatility index of the United States. And we analyzed the VIX on the sentiment of Chinese investors. We collected the comments related to the stock on Sinan Weibo from 2019 to 2023 and classified all comments using sentiment analysis with slow NLP. Based on this, we construct the Chinese Investor Sentiment Index, which is CISI. Then we study the relationship between VS and the CISI using Pearson correlation, linear test, and gradual causality test. And we found that the influence of the VS on Chinese investor sentiment is not significant. However, we observe a positive correlation between the Chinese stock index and the sentiment in the comments. Therefore, we conclude that the sentiment in the US stock market is relatively independent from the sentiment of Chinese investors. And the next page is the introduction of our project. There are background and the motivation. Firstly is the background. We know that the US VX can measure the market's expectation for future volatility and is often considered the sentiment of the US investors. Moreover, the US stock market can influence the global financial market. Next is the motivation of our project. We want to quantify the Chinese stock market sentiment through social comments. And we also want to analyze the relationship between Chinese stock market sentiment and VIX. And the next page is the literature review of our project. Here are two major functions. There are two major reference of our project, and both of them can introduce the function of the sentiment analysis. And the first reference is stock closing price prediction based on sentiment analysis and LSTM. And this article improved the stock price prediction accuracy and efficiency through adding sentiment analysis. And the second article is using time series and sentiment analysis to detect the determinants of Bitcoin prices. This article forecasts the Bitcoin's price using a spot vector machine with the variable of common sentiment and got better result. Both of these two references can improve the prediction accuracy using the sentiment analysis. So, and the next page is the methodology of our project. Firstly, is the flow chart. And the first stage, we collect the data of the comment from the Sinan Weibo, and then we made a sentiment analysis for the comment before. Next, we calculate the CISI from the sentiment analysis result. Lastly, we implement the Pearson correlation, linear regression, and the gradual causality test for the CISI and the VX. Regard to the data collection, there are two major data sets. The first one is the Chinese stock market social comments, and the second one is the VX. Regards to the Chinese stock market social media, social comments, we collect the comments from Sinan Weibo that contain keywords such as stock market, and A shares. And the daily data of the VIX can be downloaded from Yahoo Finance directly. And regard to the sentiment analysis, we choose the slow NLP for it. The slow NLP can implement the sentiment analysis for a given Chinese text. And the text can be classified as positive and negative sentiment. If the value nearly 1, then that is a positive sentiment. If the value is approaching 0, then the comment is a negative sentiment. The next page is the calculation of the sentiment index. If we want to calculate the CISI, we have to get the proportion of POS and the NEG. The POS is the positive sentiment comments, and the NEG is the negative sentiment comments. And we have to get the proportion of these two comments respectively. And then we calculate the Chinese investor sentiment index by the following equation, which is the CISI. And after we get the CISI, we have to detect the relationship between the CISI and the VIX. Here are three major methods for the detection. The first one is a Pearson correlation. We can check whether the coefficient is significantly different from 0. Secondly is the linear correlation. We build a regression model for the CISI and the VIX, and then we check whether the slope is significantly different from 0 using the linear regression. And the last method is the gradual causality test. We check the p-value, whether it is lower than 0.05. And the next page is the empirical result and the analysis. Firstly is the data description and the cleaning. The data set of Chinese stock market social comments have nearly 119 comments, and they are daily data. And the data is from January 1st, 2019 to November 15th, 2023. Alternatively, the daily data of VIX closing price can be obtained from Yahoo Finance, and there are totally 1,228 data points. And the data is from December 31st, 2018 to November 14th, 2023. The Commons dataset lagged behind the VIX dataset by 1 day. This is because of the time differences between these two countries. So the data from China requires a 1-day adjustment with the VIX data. Here are two pictures here, and they are the time series plot of these two datasets. And the next page is the result of our model. Firstly, we detect the relationship between VIX and the CISI. Regards to the Pearson correlation, to compute the confidence interval of their coefficient, we generating 1,000 samples using bootstrap method. And the confidence interval for the Pearson correlation coefficient between these two datasets is negative 0.025 to 0.066. And we can see that 0 is in the confidence interval. Secondly is the linear correlation. We implement the linear regression of two time series. But however, the t-statistic of the slope is 0.7187. And we cannot conclude they have the linear relationship because the slope is not significantly different from 0. Lastly is the gradual causality test. Both lag 1 and lag 2, the p-value are high, so VIX is not gradual causal to CISI. now we get the result between the VS and CSI, and the relation is not significantly. And we also want to prove the method is efficient. So we also try to analyze the relationship between CISI and the Chinese stock market. And we collect the daily return of the Shanghai Composite Index, which is the major stock index in China. And the data set is from January 1st, 2019 to November 15th, 2023. This is a new time series, and we also use these three methods to calculate the relationship between CSI and this new time series. Firstly is the Pearson correlation. The coefficient is 0.1734, and the confidence interval is 0.115 to 0.232, and we can see that 0 is not in the confidence interval. So we conclude that the coefficient is significantly different from 0. Next is the linear correlation. The coefficient of the slope is 16.4, and the standard error of the slope is 2.7, and the t-statistic for the slope is 6.08. So the slope is significantly different to 0. Lastly is the Granger causality test. Both lag 1 and lag 2, the p-value are high. So the Chinese stock market return is not Granger causal to CISI. And based on the result above, we can get the conclusion here. According to the Pearson correlation, linear correlation, and the Granger causality test, there is no obvious correlation between CISI and VX. So the VX cannot influence the sentiment of Chinese investors. Although the Chinese stock market return is not Granger causal to CISI, the Pearson's correlation and the linear correlation show that Chinese stock market return has positive correlation to CISI. So the Chinese stock market return can affect the CISI with a positive effect. Okay, that's all my presentation today, and thank you for the listening.
Thank you so much for your presentation, Zuchin. It was an interesting topic, like regarding the text sentiment analysis or market sentiment. Quite an interesting, like it's like my first time hearing this. So I hope you will be excelling in your future works or endeavors. So thank you so much for your time. And before I end this, is there any question from the floor to Zushin? If you have any, you can proceed before we have a photo session and end the session. If no, then I think I request all the presenters to switch on your camera so that we can have a memory captured. So I took hold on. Okay, so 1, 2, 3. Sanadi, can you open your camera? Switch on your camera if you are there. Okay. 1, 2. Smile. 1, 2, 3. Have another one. All right. Thank you so much, and congratulations for presenting in SDM. And we really appreciate your time, your contribution to our conference, and we really appreciate it. Till we meet again in our next SCDM. Thank you so much. Bye-bye. Have a good day.